So far, what you have been discussing regarding the probability distributions, I think we are somewhat lucky because our university has purchased the license version through Learn. I think without the 40 minutes barrier, I think we'll be able to continue the lectures without a break. I think we expect many students to join today, of course, to continue this online delivery. I just like to summarize what I've done so far. I think some of the students find it difficult to understand the probability distribution. One of the difficult part in the probability. So far discussed the very elementary things now, mutual exclusive one and non-mutual exclusive one, the combined one, then independent and dependent events. So and tree diagram, those are very elementary things in probability. But this is the important part in probability calculation for the industrial application. This is the very important part in probability, the distributions. We are supposed to finish this one today because you want to start the next module, the differentiation, the calculus part today, right? Even other class also, we just started the probability differentiation. So we hope to summarize initially what we have done so far quickly. And I just modify the slides also, add some more examples. So in order to understand the concept well. Remember, if you have any doubt, please, you can raise questions anytime to clarify the matters. And some exercise also you are supposed to do. Remember, you have to have some piece of paper ready to do some exercise also while this is going on. Okay, now I think 10 students registered or joined today. This particular batch, actually very few students registered. Normally other batches there will be 20-25. But we can't wait so long because you are joining from your home, so you'll be able to join in time. Now this is the, I'm not going to use the what you call the slideshow mode because I just want to summarize the quickly what you have done so far. I can see the definition of the random variable. I just quickly summarize, right? Very important thing. Earlier, what we practiced the sample space. Sample space normally consists of many times characters. There are some cases even numbers also. For example, tossed I 1 to 6. That is a numeric. But most of the occasion, sample space may be in practical situations, maybe in different way. Normally characters like H, likewise. When it comes to range space, the purpose is to convert the sample space to numeric values by defining the random variable x. This is a good example. This is the toss a coin 3 times. Those who find it difficult to understand, just try to understand now. I have added some more examples also today. You see the toss a coin 3 times. This is a very obvious sample space. You see the three whole categories, of course, 3 T's, but in addition, you see the first underlying part is the 2H and 1T, other one is the 1H and the 2T. The possibility of having the 1H and 2T or 2H and 1T is a high probability. You see the possibilities, the 3 possibilities are there. And if you define the event variable x, of course, the number of x, then you can actually easily find out the number of weights. See the next slide, I just changed some of the things you can understand easily. See I just modify the previous slide. Some students find it difficult to understand the concept. See the event is this one very clear. Now we'll be to understand clearly. I just change it, right? What will be the number of weights? Respect to here 3. In each occasion, you see the 2, 2, 2. Here 1, 1, 1. Here 0. This is how we convert the sample space to numeric value. Right? So number of weights, what are the the different values for the number of weights, 0, 1, 2, 3, right? Now number of weights is, this is called a range space, x equals 0, 1, 2, 3. And you can understand how you get the 0, 1, 2, 3. 3 T's mean no heads, 0 heads. This category, 1 head. This category, 2 heads. This category, 3 heads. That's how you get the probability. This is called the probability distribution. See the 0 only once, 1 upon 8. 3 heads again only one times, 1 upon, but the 2 heads or 1 head, it has many times, 3 times, 3 upon 8, 3 upon 8. If you add this all together, you get the 8 by 8, that is 1. Now, to understand the next part, the binomial distribution, this will help you remember. And this is a good example we can use anytime to to explain the binomial distribution. Remember how we get these probabilities, right? To quickly go to the next one. Next slide. This is the actually range space. Normally the 0, 1, 2, 3 instead of 0, 1, 2, 3. So generally we have the random variable, likewise x1, x2, x3, x4. This is a range space, of course, range space. And this at the bottom of the screen you can see the, actually you have seen this one in the previous slides also, the probability distribution of the variable. The same thing displayed earlier, right? Then we quickly go to some exercises. I think the exercise also are just slightly changed. You can remember, now remember this has been discussing for the second time. I will be able to understand. I just like to explain very slowly because binomial distribution you can understand easily if you can understand this kind of thing. And take the first exercise, the pair of 6. Now today also I have different example also, exercise also to you, right? Everybody should have some papers ready. Pair of 6-sided die is tossed. The value x is now defined as the sum of the numbers, and a pair of 6-sided die means, I think several times I explained, no? The die consists of the 6 sides. Each side printed the number. What are the number? 1 to 6. 1 dot, 2 dot, 3 dot, 4 dot, 5 dot, 6 dot, likewise. We thought that the 2 dice, of course, the sample space, I think, and I think we have the next slide. So we want to calculate the probability distribution of x, right? X is a sum of the 2 numbers. If you go to the next slide, you see the sample space. I just modify, you can understand what are the different possible outcomes. This is not the what we call the range space. This is a sample space. Remember, if you pair of 6-sided die is tossed, variable x is defined as the sum of the numbers. We didn't come to that particular part yet, but this is the sample space. You look at the diagram. So this is this one. Now you see the slide clear. This one, numbers 1 to 6. These 2 numbers 1 to 6. So these are the possible outcomes. See the written outcome in the previous slide. The slide you used the previous day. We didn't show these values, but I added because some people find it difficult to understand this concept. Because so you are everybody having the very poor foundation knowledge. So that is the problem. Normally, in the other courses like CTR and construction technology, BST students, particularly part-timers, we are not going to explain, using these kind of very elementary things. They can understand easily because they have many of them done A-level mathematics. Quickly we can explain, but to teach the ICT students very difficult because they find it difficult to understand very elementary things. You see here the 36 sample space. These outcomes are specified here. 1, 1, 1, 2, 1, 3. What are the first number represent every time the die 1 number, second number die 2 number. Observe like that. Actually, all possible outcomes are these outcomes, right? And now try to understand everything, right? Now, what is our aim is we take the sum. See, take each of the outcome and add the 2 numbers. So what are the numbers you get? The minimum number you get 1 plus 1, 2. The maximum number you get 6 plus 3, that is 2. Right? in between 1 and 12, you get all other total, no? 3, 4, 5, 6, all get, because 1, 3 give 4, 1, 2 give 3, 3, 4 give 7, 4, 5 give 9, 5, 5 give 10, 6, 5 get 11, 6, 6 get 12. But the frequencies are different. That is the thing some students find it difficult to understand. So I just modify the slide next time so you can understand. Still, that is continued. The slide is repeating this. We go to the next one, we can understand. Yes, see now see the x defined as the sum of the numbers. Therefore, the range is just talking about, no, 2, 3 up to 12. Now see the diagram. Just modify. If you have a question, please raise quickly. Any question? Now see the diagram. I think everybody can see the diagram. No, file is shared. PowerPoint presentation is shared. If you can't see it, quickly inform.
No.
Huh?
No, we cannot get.
You can't see the slide?
We can see the slide. Okay.
No, that has been shared.
I think you sent to the presentation via email.
That is this pic is not there because that's why the issue. Maybe yesterday, maybe day before yesterday, I just modified the slide. In your printed version, this slide is not there. You have this one, right? You have this one, not this one. You have the previous one. Even this one, you have only the graph here, right? The print hard copy is maybe slightly different because some stuff find it difficult. So I just modified the slide. Now see the maybe slightly different what you see in your hard copies, because now see the total I put it here. If you add the two numbers, see at the cross, you just add the total. You see now, this is 2, this is 12. So you can understand now how many, the frequency, of course, the 3 only 2 times. This only 2. 4 can be have 4 times. 5 total can be have 4 times. The frequencies are different. The 6 total can be have 1, 2, 3, 4, 5. 7 is the maximum number. See, 1, 2, 3, 4, 5, 6. Because 7 can be have either 1, 6, see, then 2, 5, then 3, 4, 4, 3, 5, 2, 6, 1. See, actually, if you do this kind of experiment, we can expect many times the total 7, because the possibility is high. It has a high probability, high possibility. That's what to prepare this particular slide. Now we can understand easily. To prepare the probability distribution, see, probability P, what is the probability to get in 2? Only once, right? Similarly, probability to get in 12 only once. But if you take the number 3, 2 times, no? How to get the 3 total 2 times? First die 1, second die 2. Sometimes it can have first die 2, second die 1. The possibilities are high. 2 possibilities are there. That is how how we calculate the probabilities. I think you can understand well now. Similarly, see the 3, 4, 5. Number 6, 5 times. Number 6, 6 times. 8, 5 times. Similarly, you get if you add all these numbers, finally you get the 36 by 36, 1. The total probability will be 1. This is the feature of the probability distribution, remember. In practically, there are many probability distributions, the industrial application. We have now in your syllabus, we have only the binomial distribution and the normal distribution, but there are many probability distribution. In research, when you're supposed to conduct research and you are supposed to do masters in future, the T distribution, chi-square distribution, Poisson distribution. There are so many probability distributions. They are very useful. Normal distribution is a very useful one, all out of them. Right? Go to the next exercise quickly. The coin toss 4 times, and variable x is defined as the number of heads. Find the probability. In this case, what is the outcomes either? These are the previous one displayed. I have to Yes, this is the next toss a coin 4 times. Toss a coin 4 times. X defines as the number of heads. Remember, X defines as the number of heads this time. And if you find it difficult to find out all possible outcomes, just draw the T diagram. This has been shown the second time. Remember, this is a T diagram. Normally we show, maybe this also may not be included in your presentation. I think I will be able to send it, everybody the latest version. These are the all these are the all possible outcomes. If you do remember this concept can be extended to any number of times. The toss, for a toss in any number of times, 4 times, 5 times, 6 times. You can extend the tree. That's all. You see the all head, 4 heads, then the 3 heads and 1 T, 2 heads and two T's. Likewise, all possible outcome can be easily found. Actually, these can be categorized into actually four categories: 4H, 4Ts, 3H and 1T, 2H and 2T, 1H and 3Ts. Actually, we have 4 visible categories. You can easily identify when we get the 4Hs or 4Ts, 3Hs and 1T, 2H and 2Ts, and 1H and 3T. But the possibility, the frequency is different. The frequency is actually 4H only one, 4T only one, 3H and 1T, the 4 times. See the red in red color 4 times. The maximum you get 2H and 2T. How many times? 6 times. To observe that, therefore that the frequency is different. Finally, you get the frequency. So actually, I have arranged all the outcomes in as a sample space. This is sample. Now you'll be able to understand what is the the number of heads. Range space is 43210. I just changed this slide also because some of the students were asking why starting 0, because this is 4H. In order, I just prepare initially 4H. The second category 3H. The third category 2H. See how many possibilities are there? 6 possibilities are there. For the 2H and 2T, see HHTT, THHT, HTTH, then THTH, TTHH, THHT. See, so many possibilities. 6 possibilities are there. This is called, I mentioned, mathematical modeling. Actually, all 16 outcomes, if you take separately, have the same probability. But now it's a different case because now we X define as the number of heads. In this particular order, see the number of heads. So, number of heads 3, 2, but frequency is different. Probability 4, 1 upon 16. Number of heads 3, how many? 1, 2, 3, 4. 4 upon 16. Number of heads 2, 6 values are there. So 6 by 16, 4 by 16, 1 by 16. Actually, now when you have the probability distribution, the in correct form, normally we are not writing 4 to 0, 0 to 4, 1, 0, 1, 2, 3, 4. These are the respective probabilities. If you add these probabilities, you get actually 16 by 16, no? 16 by 16, that is 1. Another thing, the first semester, I think we have done, can you remember the normal binomial distribution, binomial theorem? This is the a plus b to the power of 4 coefficients. This is for 1 mean 4C0, 4C1, 4, 4C2, 6, 4C3, 4, 4C4, 1. Same binomial values actually we get, frequencies. That can be extended even in a number of, not only the coin toss, any probability distribution. Normally we define the Bernoulli with 2 outcomes. This can be used binomial distribution. Actually, binomial distribution can be used only for the 2 outcomes, like H and T. That's a very famous one, but in some of the industrial applications, that can be, the damaged one, not damaged, likewise. They quickly go through the same thing. Maybe this different now. See that I just give another example. The 2 numbers from 1 to 3 are chosen. I think this is I explained earlier also, right? There are 3 numbers, 1, 2, 3. Now we are selecting 2 numbers. Very simple logic. Out of 1, 2, 3 number, we are at a time we are selecting 2 numbers. Another condition also given, repetitions are allowed. Repetition means 1, 1, 2, 2, 3, 3. So what are the all possibilities? Now this is the mathematical modeling part. You have to have all possibilities. 1, 1, 1, 2, 1, 3. Then you can have 2, 1, 2, 2, 2, 3. 3, 1, 3, 2, 3, 3. 9. Again we define x is the sum of the numbers. Because we want to have the sample space, range space, probability random probability distribution. We want to calculate the random variable. Random variable x is the sum of numbers here. 1, 1, 2, only once. 6 can be having only once, but other value 2, 3, 5 many times. 4 can be have 3 times, no maximum. 2, 2, 1, 3, 3, 1. So therefore, this is a probability distribution again. Same feature. If you add 9, if you add these fractions, again 9 by 9, you get 1. Now just add some, the exercise for you. Everybody now, about 15 students join now. Everybody then just take a piece of paper and just add some new exercise to you. This one. A pair of 6 sides, same example we used early, but the variable different this time. Take this one. You see the task to students. The pair of 6-sided die is tossed. The variable x is defined as the difference of the two numbers appear. Remember, earlier we consider the sum, the total of the two numbers appear. Then we get the what we call 2 to 12, no, 2 to 12. Now this is the difference. How do you get the, prepare the frequency distribution? I just advise you to initially have the whole sample space and mark the earlier, can you remember you marked the sum? Similarly, just mark the difference. I just want to go back to the particular slide and show you. Can you see here? This is the same exercise. Everybody, you see the different slide now. Everybody can see now. This is what we call the sum. If you add the two numbers from the die 1, die 2, you get the sum. What they now define as the difference. Remember, every difference only positive. Take, right? Or take only the positive difference. Just slightly, some assumption, of course. All should be, whatever the difference should be a positive number. Just mark the difference value. I just want to emphasize. Now tell me now, those who already started, tell me now, what are the minimum, what are the range of course? What are the expected x values? What is the minimum value expected? What is the maximum value expected? Based on this definition. Read it again. Pair of 6-sided dice is tossed. The variable x is defined as the difference of the two numbers appears. Right now, for example, if one die display 4, other one display 1, difference is 3, right? Even display other 1, 4 order, again difference is positive. In that way, we take positive every time. The deduct the small number from the big number. That's what Then try to do yourself now. Tell me now, those who finish, what is the minimum number you can expect here as x? What is the minimum number we can expect? What is the answer? The minimum number we can expect. Now we are taking the difference, right? Earlier we considered the sum, now consider the difference. Just switch on your microphone and tell one by one answer. What is the minimum difference you can expect? And what is the maximum number you can expect? We can send the answers also, some can send the answer. Some are sending their comments. Just Give me the answer. The minimum can't be 1, no? What is the difference? Minimum difference, what is the maximum difference? You take the same example, no? I just asking the same example. What is the minimum, what is the maximum? Remember, when we come to the assessment, if you see the past papers, actually we rarely get the question from the probability distribution. For normal distribution, sometimes you get the question because the normal distribution. I think everybody should have some normal distribution table ready, no? I think everybody have the normal distribution table ready with you. Some will say the maximum value 5, that is correct. Minimum value, not the 1, remember. Minimum value, not, but the minimum value, you can expect the difference. Hmm? What is the minimum value you expect? Yes, okay, we go for the next slide with the answer. This is a different slide. I have to go. This is the slide we require. This is the normal same outcomes. See, same outcomes. These are the outcomes. Actually, in this case also, when you toss a die 2 times, this normal so normal 36 outcomes. X defines as the difference of the two numbers. X defines as the difference of the two numbers appears. See the two numbers appear now? What is the difference? Minimum difference you get one in this first one, 1 minus 1, 0, 2 minus 2, 0, 3 minus 3, 0. Those are the things, the different maximum difference you can have, 6 minus 1, that is 5. Now you see the difference diagram here. I think you will be able to understand now the difference, right? You can understand the difference now. Die 1, see die 1, 2 and die 2. These are in the middle you see the difference has been displayed. The 0 getting maximum frequency, not maximum. Actually 0 getting 6. The maximum you get the 1. 1 can have many times. See the number 1 difference is in both sides. Here also it has the number 1 difference. You take the difference of the two number appear. Can you see the frequency now? 0, 6, 1, 10, 2, 8, 3, 6, 4, 4, 5, 2, 5 only 2. See, 5 can have difference in the either 6, 6, 1 or 1, 6. See, only two times. This is the additional exercise actually I have added to the previous total. I think this is actually you can understand what is the probability distribution. I think the next part is, I think you can remember we explained the Bernoulli trial. Bernoulli trial means the we have only two outcomes like head and tail. Any random experiment whose results has only two outcomes, which we call the success with probability P and failure with probability Q. This is the P success is P, and failure is Q. Generally, P plus Q equal 1. Then the Bernoulli binomial distribution says probability of R successes in Bernoulli trials, that is PRN. NCR, this is NCR notation. Remember, we have done in the first semester, NCR, PR, Q to the power N minus R. Then we take some example. See, I take example, you can understand. Bernoulli trial example, toss a coin 4 times, right? Toss a coin 4 times. I think with this example, we have considered earlier, can remember 16 outcomes were there, 16 outcomes. 16 outcomes were there. Any random experiment whose result has only 2 outcomes. In a random experiment whose results has only 2 outcomes, which we call the success with probability P and failure with the probability Q. Here see the very elementary way I just explained. Probability success means H. Suppose if you get in H, that is success. The failure T. If you get a T, here is a failure. You assume that, right? Then the probability getting P or Q both is half. So you can now calculate about formula we have seen in the previous slide to calculate the three successes. 3H, actually getting 3H. That's all, getting 3H. How to get probability? 4C3, P3, Q to the power 4 minus 3. This is how the binomial distribution is used. If you simplify, you get 1 upon 4. If you toss a coin 5 times, find the probability of getting 2H and 3Ts. All combination of the H and T's, you'll be able to calculate. Here asking 2 successors. That means 2H out of when you toss the coin 5 times. 5C2, P2, Q to the power 5 minus 2. If you simplify, 5C2 is a 10. Okay, you know how to calculate the factorial values. 1418, 14 the P2, Q3 mean 1 upon 8, 10 by 32. Then 32 is the total number of outcomes. You get at least 10 possibilities. In the last previously also explained the same example. No? What are the possibilities? So with 3H and 3 T's. 2H and 3 T's. Just ask you to write the 10 possibilities. Just ask you to write the 10 possibilities will be displayed in the next slide. See that all 10 possibilities. If you observe, has only the 2 and 3 T's. Each of them has the 2 and 3, but it can be happen in different manner. That's what this is being specified in different way. What is the different mean? The first number represent first toss, second one second toss, third toss, fourth toss, fifth toss. Likewise, the different. Actually, we get 10 possible ways. You can't even believe, no? Even these particular 2 and 3 T's can be have in ways. I think I add some additional exercise after this. This is another example. Toss a coin 3 times. All the previous example we can actually simplify. You get the answer very easily using binomial distribution. Toss a coin 3 times. Suppose H is the success, T is a failure, PH5, PT5. So P.5 is Q.5 both. The 2 successes, what is the probability? 3 P3 2, P3 2, P2 Q3 minus 2. Simplify 3 by 8. Can we get the same answer earlier also? 2H, but getting the probability of 2H, 3 by 8. Now we extend concept, the actually remember in this case get 64 outcomes. If you draw the T diagram, you get the 64 outcomes. A fair coin is tossed 6 times, cold heads is a success. Cold heads is a success. Then N is 6, P equal Q equal half. And the probability that exactly 2 occur is R is equal to then the use the formula 6C2 P2 Q 6 minus 2. Simplify, you get 15 upon 64. Now this is very interesting. The possible different outcomes. How many? 15 outcomes are there to get the two different two heads. Which means others are T, 2H and 40s. See? The probability that exactly 2H of you get every time 2H other is T. The one option is TT, HH, 40s. That just practice if you want. To learn, this kind of thing. You are in the second semester. Syllabus is some advanced concept has to be discussed because in the next two couple of modules, the differentiation is a calculus part. Remember, the engineering cannot be the study without the calculus. The 90% of the whole engineering actually based on the calculus. Okay, now this is the similarly, the probability getting at least 4 hits. At least 4 hits means you have to add all the probabilities. The P at least 4 hits means 4, 5, 6. All can be have P probability 4, probability 5, probability 6. Add all the probabilities. Then you get 0.34. I think I just have some, these are some actually exercise that will be explained this since the previous day also. I think I had some different exercise, maybe after this, I think. Yes, after this. See, I think they explained this in previous day also. Remember, this is the application of the binomial theorem. This is the application of the binomial theorem. The package contains 50 similar components, and inspection showed that 4 have been damaged during the transit. Out of 5, 4 damaged. Now we can calculate the probability. What is the probability of damage? 4 by 50. 4 by 50. Not damage means 46 by damage probability is very less. Damage probability is very less. Now similarly, this one also same. Just see the answer there. So see the answers here. Probability damage 4 by 50. Now this is explaining second time. Remember. Probability damage 4 by 60. That is 0.8. 0.08. So probability not damage 1 minus 0.9.92. High not damage probability, high probability. No. Then you see the getting 1 damage, 6C1. We are choosing 6 components. So read the question. If 6 components are drawn at random, out of 50, we are selecting 6. Then asking calculate out of 6 probability in the sample 1 and less than 3 damage. That's the question. Those are the questions. This 6C1 P1 Q 6 minus 1. Simplify. You have to use the calculator to get this value. You get 3164. Probability less than 3 damage means less than 3 means with 0 damage, 1 damage, 2 damage. Likewise, you can get the this can be simplified. No, you can see the answer 9914. I just add some can. The pair point is to 6 times. Remember, the cold head is a success. Now again we define the variable x is defined a number of heads and find the probability distribution of heads. How to calculate? How to do this kind of thing? Find the probability distribution of the x variable. X is the number of heads. Here you see the if you toss open 6 times, we can easily find out range space. Number of tests could be 0, 1, 2, 3, 4, 5, 6. 0 means all 6 times you get tails, right? What is 6? Maximum value 6. All 6 times you get. So in between you can have many, no? In between you can have many. But remember, when you continue this, very difficult to draw. Very difficult to draw. So therefore, just some students saying the other lecturers were not charged. Lectures were not charged with the data. They provide free link. This is not a free link. I just log in with the username and password. Remember, this also actually you won't cross the link because this has been running through Learn. Data should be free. I don't know how do you arrange that one. If you want to me, just talk because just log in with the Learn. from I think onwards, not maybe Friday onwards. Lectures, see the notes 40 minutes daily. I don't know, you have to the talk to the university and get that kind of arrangement. Even other lecturers also, and using the same software. I don't know why only for the lectures cost. That can't be. I arrange that because even other lecturers also use the username and password through Learn, right? It can't be there to feel it is not free. Talk to the university because I just log into the this conducting through Learn. Definitely, data should be free. I don't know about that. Now see the probability distribution. How to get this probability? See the Fairtoin. This is the additional slide I have added. That to explain this binomial distribution because some system find it difficult. Now see how simple this one. A pair of coin is tossed 6 times. Called it is a success. X is the defined number of fates. Find the probability distribution. The range is space, very obvious, no? Number of fates can be 0, 1, 2, up to 6. Now, see the probabilities can be calculated in this way. Other than the tree diagram, you will be able to understand how simple this way that other than the tree diagram. 6 probability binomial distribution. Number of fates 0. 6C0, 50, Q1, 61, P1, Q5. 5 means 6 minus 1. 6C2, P2, Q, 6 minus 2, that is 2. Then 6C3, P3, Q, 6 minus 3, that is 3. So similarly, you get all the probabilities. See? Now you'll be able to calculate the value. 6C0 is 1, 6C1 is 6. And you can't forget what you learned in the first semester. You have to remember binomial distribution, binomial theorem we did know. 62 is a 15, 63 is a 20, again 64 means 62, again 15, this is 65 means 61, again 6, this is 1, 66, again 1. Then other probabilities can be calculated. The P is a half, Q also half. Remember, it's not specified here, but P, I can specify here. So the P is half, 6, Q also half. Based on the calculation, you see the probabilities you get. See probabilities. 1 upon 64. 0, number of 0 8, only once. 1 upon 1 8 by 64. 2 8 15 times. 3 8 20 times. 4 8 15 times. 5 8 6 8 1 time. This probability is 15 20. 15 6 1. You get 64. 64 by 64. Probability binomial distribution when the experiment has only the two outcomes. Right? When the experiment has only two outcomes. But try to contact the coordinator and talk to him regarding the comments. Regarding the how do you? I think that yes. If you have problems, tell me. The others also everybody cost the internet for the mathematics because I running through the Learn this software. So, it should be free. It should be free. It's not just talk to the university, right? And that I cannot control those matters. Now see some example, the concrete block example. So these are practical example, practical usefulness of this kind of things. See, the practical heavily used in industry application. This is engineering application, the concrete blocks are tested and it is specification. When the concrete blocks are manufactured, they make some concrete blocks. They after that they test those. Maybe they are selecting samples and test that kind of a survey reveals actually 7% fail to meet the required specification. The big percentage, no. With the industrial, it's a successful industry. 7% fail means it's not very good. But if you make 100 concrete blocks, 7 is fail. But it's the only example, right? It is asking for batch of 9 blocks. Suppose if you sell on 9 blocks to somebody, determine the probability that 3 blocks and less than 4 blocks will fail to meet the specification. Now, P, the probability success is 0.07. The failure percentage is asking. No? Our P is 0.7, Q is 9.3 every time. Now, what is the 3 fail out of 9? But you will understand this kind of thing. I think some of the students find it difficult to understand, because some of you have very poor knowledge in mathematics. Even some fail GC or whatever also, right? Then remember those people, I don't think you get the degree, right? You have to, otherwise you have to improve your mathematics knowledge. We are actually covering the syllabus, right? The syllabus is given to us. If you see the second year syllabus, it has the binomial distribution and the normal distribution, right? If you take the syllabus from the university, or I can send you if you want, it has this content, remember, binomial distribution and the, what we call the normal distribution. Even if you refer some tables, you will not be able to, that this kind of clarification example. I have actually tried very much to explain this concept, as simple as possible. That's what additional effort has been made. And if you don't have the initial mathematics knowledge, you won't get the degree also, right? Remember, some students I just saw some comments made about this subject. Actually, I am not really worried about those some of the foolish students' comments. Right? I am really not, but I don't even anytime I can stop this delivering, right? I don't like, I actually be conducting these lectures, the faith of the students, because they are, you want to get the degree as soon as possible, no? Even this problem, if you don't have the required mathematics knowledge, nobody can help, right? Unless you, improve your mathematics knowledge. What we are doing is, to cover the syllabus content given, as simple as possible, right? Understand that matters also. You see the P is 0.7, Q is 0.93. The 9C3 out of 9, understand this. Out of 9 blocks, how many, what is the possibility of each of 9 blocks? What is the probability? 3 damage, because so many outcomes are there. Now, you are choosing 9 blocks. For example, you have to actually have 9C0, 0 failures, the 0 failures, 1 failure, 2 failures, 3, 4, 5, 6, 7, 8, 9 failures. All possible outcomes has to be considered. See, can you write the sample space? Very difficult. But we can write the the probabilities you can easily get without the 9C0, 9C1, 9C2, 9C3. Very difficult. Actually, what is the value you get? 2 to the power 9. Sample all possible outcomes are binomial theorem can be applied. What is the Bernoulli right here? If you select concrete block, 2 options, either damage or not, no. damage for probability 0.7, not damage 93. If it is head and tail concept, all half. But in the practical application, that is different. Half also 1, 0.07, 0.93 also half. This is a Bernoulli trial. The selected concrete block can be either damaged or not damaged. Remember. And if you select 9 blocks, how many outcomes are there? This thing, something like a toss a coin 9 times. Likewise, right? Toss a coin 9 times. Either fail or not fail. If you have 9 blocks, select 2 to the power 9. 2 to the power 9 means 512 outcomes are there. Remember, can you write 512 outcomes? That's what you use these theories, remember. And if you have some common sense or some intelligence, you'll be able to understand what I am telling. 2 to the power 9 means 512. Can you write the 512 outcomes? Very difficult, no? But easily see the how simple in one line we can do the calculation. Out of 9, 3 damage probabilities, 9C3. Just one formula to remember. Right? What is probability? NCR, PR, Q, and minus R. The probability, the formula I mentioned earlier. Here. And this probability, see. That's what it highlighted in big character. Remember, this is a Bernoulli polynomial distribution. Any out of n, here n is 9, R is 3, 9C3 every time. Out of 9, 3 fail. So likewise, this can be applied to any situation. Let me work in just that one. We have been discussing this one. We were here, right? Can you remember? Out of 9, 3 damage, PC3, Q3, P3, Q9 minus 3, 84. How do you get 84? 9C3. The first semester, use your knowledge, 9C3. 9C3 means factorial 9. Factorial 9 divided by factorial 9 minus 3 and factorial 3. If you simplify, you get 84. The previous day, some students, how do you get 84? Because they can't remember what you have done in the first semester. You have to remember what you have done in the first semester. 9C3 means factorial 9, factorial 3 divided by then factorial 6 and factorial 3. If you simplify, you get 84. The P mean now P is not half this time, 0.7 power 3, 0.93 power 6. You have to use the calculator to simplify. Then you get the answer given. This has been taken from textbook, these questions. Answer also I just copy to the same answer, 0186. If you multiply these particular 3 numbers, you get. Similarly, the second part, less than 4 blocks will fail. Less than 4 blocks mean you have to add 9C0, 9C1, 9C2, 9C3. All probabilities has to be added. Less than 3 fail. Less than 3 fail. You have to add all probabilities. Then get this particular answer. I think even if you see your past papers, you won't get many questions from the binomial distribution. That is also for the sake of you. We are not given any complex questions, so everybody can easily pass through these particular units. Now we are actually doing in that way, right? We are actually doing in that way, but some students, given some unwanted comments, right? If you can't understand this matter, mind your own business, right? And remember that you won't get the degree also. But finally, you have to show your competence at the end. Now, actually, we have finished that particular part. I think this is the place we supposed to start, right? I can remember I just sent with the email that everybody got that, no? Have you got the mail? It's a table, PDF document I sent.
Yes, sir.
Have you got the what copy? The hard copy? Have you got a printout of the? It's a table, only 2 page. You haven't got. I just asked you to. I just asked you to have the hard copy of the normal distribution table. There's only two-page table because you will not be able to do exercise yourself without that table. The purpose of sending that table, but with the online, you also in the computer, the mobile phone, no. At the same time, you can open the soft copy, no. That's what I asked you to have the hard copy of the normal distribution table. Anybody having? Nobody having the normal distribution table? What about the others?
Having, sir.
Better to have the hard copy of the normal distribution table. Otherwise, you'll not be able to do exercise. I can explain because the PowerPoint slides I have added the sample tables. But when you do exercise yourself, you should have the hard copies, right? Okay, remember this is a very important distribution, normal distribution. Even the Z score calculation, normally examination department do. Not only that, any research projects, you can't do anything without the normal distribution. Most of the industrial teams and the quality control, sampling distribution, industrial application. This is very important. Distribution actually, we just finished the binomial distribution. This is called the normal distribution. Remember. This complex equation actually you need not to remember. I just explained your requirement is very simple. Remember, this is very simple than the binomial distribution, but we were very useful than the binomial distribution. But some of the theories part is very difficult, but you need not to understand actually, right? Remember, you want to understand only a small thing about the normal distribution. Some of the slides actually were not here. I just explain yourself because before I describe this particular normal random variable, I can now remember what you have done in the first semester, right? Remember what you have done in the first semester in the statistics. And remember, we done two parts, no? Measure of central tendency and the measure of dispersion. Out of that, then we practice some graphical representation, also very simple, histogram. Histogram you can remember. Then if you join the midpoints of the histograms, that become a frequency polygon. I think you can remember that kind of thing, right? Frequency polygon. I can't open some other, so there are slides to explain that kind of thing, but I think you can remember. No? And that knowledge is required to start this. Then we calculate mean and the standard deviation. Remember, mean is the central measure of central tendency, like average. Mean is average. No, the standard deviation actually a measure to see the dispersion. Dispersion means how far the observation from the mean. That is a general idea about how varies the the values, marks or whatever. If we take this example, normal distribution actually happen for the in particular kind of variables, not any variable. Normally, if you are handling with a large number of data, try to understand what I am telling now. There is nothing in the screen, right? Large number of data. I'll explain with the same simple example. I'll explain with a simple example. Suppose now GC O-level mathematics marks maybe 2019, GC O-level mathematics marks of the GC O-level 2019. Normally 500,000 students at every time, year to year, that number is increasing. Suppose 500,000 students has been set for the GC O-level. For the mathematics, you can take any subject mathematics, so English or whatever, I just take mathematics. Then you have how many marks you have? 500,000 marks, no? The examination department people, they have to record 500,000 marks for the mathematics somewhere in the computer. The minimum mark is 0. No? Some students score 0. No? Similarly, some students score total 100. Minimum marks 0, maximum marks 100. We have the 500 marks. So if you prepare the frequency distribution with the very narrow classes mean, for example, 0, 5, then 6, 11, 6, 11, then 12, 17. Likewise, with the 5 gaps, 0, 0, 5. then 611 or 610 or 610. Likewise, you can prepare. No? Then there are narrow classes. Then we have definitely 30, 40 classes. Remember, 30, maybe 30 classes. The maximum, the final class may be 9500. 9500. Right? Now, if you draw the frequency table and the histogram, normally, if you handle a large number of data, your histogram may be very symmetrical thin, very symmetrical. If you draw the frequency polygon, actually that become a very symmetrical thing, symmetrical kind of thing. Symmetrical. If you draw the actual frequency curve means the midpoint. If you join using the curve, that is the bell-shaped curve. That is called the normal distribution. It has some special properties we discuss later. This will actually apply for the large number of data, big data, not only the 30, 50 students. We cannot expect the actually the number of data, maybe more than 3,000, 4,000 is big data, right? Now, in the mathematically, we study the mathematical part. Now, the most important continuous random variable is the normal random variable. Those density function as a bell-shaped graph. The equation of the density function is the probability distribution. Remember, density function normally we call the probability density distribution. The equation of this kind of thing, exponential one, exponential x minus mu by sigma square. Remember here, the mu is the mean. These are the what you call the population parameters. Population parameter. For example, in the previous example, suppose the student average is 50, then mu is 50. Maybe standard deviation 10, then the mu sigma is 10. Likewise, remember in this formula, uh, mean is mu, standard deviation is sigma. Now you see the some properties of the normal distribution. This is the important thing. This is I mentioned the normal curve. See, if you draw the frequency distribution and histogram, and if you join the midpoints of the histogram, you get this kind of balance, bell-shaped curve. Why? If you consider a large number of observations, the majority of marks are in the middle. Remember, here in the middle is the mean. It's a mean, right? Maybe 50 or whatever, 55, 60, whatever, it's at the center. The majority of the marks are in the middle. If you conduct any exam normally, see that there's a natural thing you can understand. See the O-level mathematics. Very few students have in this area. For example, marks less than 5. The student get marks less than 5. Very small number, no? If the marks is greater than 95, also very small numbers. That's what the graph is like that. Actually, the majority, now for example, majority of the students get the mark maybe what we call the 40 and 70, maybe 30 and 70 majority. Majority of the students get the 30 and 70 marks, right? Very few get the less than 5, very few get the greater than 95, likewise. So this is the what you call bell-shaped curve. If you draw that particular curve here, this is a function. This is the actually function. The curve actually in this way. Now you see I just choose some ranges in statistics, in probability theory. Normally we use this particular range. 68% of the marks, if you consider the previous example, right? If you consider the previous example, 60% of the students' marks. You have to say like that, right? 68% of the student marks between these particular two values, mu minus sigma, mu plus sigma. If you say example, suppose these O-level marks, mean is 50, right? I just take this to simplify the concept. Mean is 60, 50. Standard deviation, suppose 10, 10 of course very big gap, right? With just example, no? Suppose mu is 50, sigma is 10. What is this range? 50 minus 10, 40. Mu minus sigma in 40. So mu plus sigma means 50 plus 10, 60. That means approximately 40 and 60. Marks 40 and 60. Actually, 68% of the students' marks are between 40 and 60. That's the meaning, right? If the marks are normally distributed. Go to the next one. 90% of the data between mu minus 2 sigma. What is the mu minus 2 sigma? 2 sigma means 20. 50 minus 20 means 30. This is 30. Minimum range is 30. Mu plus 2 sigma means 2 sigma 20 plus 50, 70. 30, 70. Example, see, 95 of the marks of course between 30, 70. Right? Similarly, 9.7. Almost all, no, almost 100. All the data may be between mu minus 3 sigma, mu plus 3 sigma range. Even 3 sigma is a 10, no? 20. This one is 20. 30 minus 20, 50 minus 30, 20. 20 other range. 50 plus 30, 80. 20, 80. Approximately we can understand 99% between 20 and 80. Like that. This is just an example. But these O-level marks, if you consider the standard deviation, maybe if the mean is 50, standard deviation may be less than 10 should be. Normally, the 90, almost all student marks, we cannot expect 20 and 80 because there are many students obtain 0, 10, 5, like that also. Just an example, right? But if the most important to understand, if the variable is normal distributed marks or whatever, remember, this is the normal pattern. So good example, the regarding normal distribution is, I think you can understand this one very well. Global IQ distribution. Remember, global IQ distribution. Global means if you take the people in all the countries, the globally there is a common fact. Average IQ of a person is 100. Remember, I think I don't know how many of you are aware of this. Average IQ of the people is 100. So mu is 100. See the graph here. Here mu is 100. The maximum IQ 145. 145. The minimum IQ is 50, 55, right? 145 means sometimes 150. There are cases 150. Minimum maybe 30. Right? Can you understand now? Minimum IQ is 30. Maximum IQ 150. Average is mean is 100 IQ. That means the majority of the people you can see the different standard deviation actually approximately 15 in that case, right? We can do calculation. Take a piece of paper, everybody can take this example. Take the IQ case. I also take paper. IQ case, the mu is 100. Write down yourself. Mu is 100. Suppose sigma is a 15. Standard deviation is 15. Assume, right? This is approximate value actually they calculate. Now, based on this particular calculation, you can do this particular range. Now, do the calculation yourself. The doing and understand and go ahead. It doesn't matter how long it takes. When you learn something, try to understand it at the same time. You can't, let it late. Suppose this example is bell-shaped curve. Mu is 100. So mu is 100. IQ distribution, not the marks. Mu is 100. Standard, write down two value. Mu is 100. Sigma is 15. Now calculate this particular range. What is mu minus sigma? Then calculate what is mu plus sigma. Similarly, calculate mu minus 2 sigma, mu plus 2 sigma, mu minus 3 sigma, mu plus 3 sigma. What are the ranges? Then you can draw the graph and mark on the table here. I'll draw the graph here, put the 100 at the center, and draw the two vertical lines as seen in this particular diagram. See the mu minus sigma, mu plus sigma. So mu plus, what is mu plus sigma now? Mu plus sigma is 115. Mu minus sigma is 85. What does it mean? 68 of the global population, can you understand? 68% of the global populations having IQ 85 and 115. This is a good example. Remember, IQ distribution is normal. Very large number of data, no? Very large number. How many, what is the global population? 700, I don't know, very big number, no? trillions, no, trillions, maybe 8 trillions, so 7 trillions, maybe very big number. Right, this value is 85, 115. Now calculate the other range, mu minus 2 sigma. 2 sigma is 30, 30. Mu is 100. 100 minus 30, 70, right? 70. Then mu plus 2 sigma, 100 plus 2 sigma means 30, 130. I can understand 95% of the people, global people, IQ in between 70 and 130. Like the normal distribution can be explained in that way very easily. Remember, 95% of the IQs in between mu minus 2 sigma and mu plus 2 sigma. That is 70 and 130. 70 and 130. If you want to calculate the two extreme ends, 3 sigma means 45. Remember, 3 sigma 45. Then mu plus 3 sigma means 145. Now you see that you get the last range I mentioned, 145. Then 100 minus 45, 3 sigma. That is 55. Right? That's what I mentioned, 55 and the 145. Two extreme ends. Almost all people's IQ, remember, almost all people IQ, almost all mean still 0.3% is there, remember, still 0.3% is there. 99%, 99.7% IQ between 55 and 145. That means the lowest IQ is we can expect the 55, the highest IQ we can expect 150, 145. But you know, there are extreme cases like Albert Einstein. I mean, his IQ may be more than 160. You know, it depends on some of the sources. Some calculation displays are nearly 180. Very extreme people, right? Maybe having IQ more than 150, very intelligent. You know, they were very rare, maybe very few people. Similarly, there are some people, very abnormal people. IQ may be less than 45, 30, 20, very abnormal people. Well, you can understand what is the normal distribution, I think. Well, it doesn't matter, it takes some time. You have to understand, right? If you have any question, you can raise regarding. If you have any question about the this normal distribution properties, right? There are many similar, you know, the example. They just give you a very popular example used everywhere. IQ distribution, even marks distribution also. We can marks distribution of the large exams. Maybe the candidates 500,000, 300,000, 10, the 1 million likewise. Remember in this graph, this equation we specify the previous diagram here, x minus mu by sigma, that is mu and sigma, normally what we practice in the first semester, mean and the standard deviation, right? I think you can go for the next slide now. Now, the table actually we are using the standard normal. Remember, now you see the Z score. Now this is the example to calculate the Z value. Normally this is actually called the Z score also, right? Z value. And you see A-level, the students offer the Z value based on this calculation. This is how we calculate actually Z score also. Z score is not mentioned here, but Z score calculation the same. The conversion from normal distribution to standard normal distribution is achieved by the substitution of the x minus mu by sigma as a separate variable we call Z. What is the assumption here? You know, the how Z equal x? Tell me now, it is here. How Z equal x? When mu is 0 and sigma is 1. That is the only case. See? How Z become x when mu is 0 and sigma is 1? That is the case we consider, remember. When mu is 0 and sigma is 1, the earlier formula, this formula become x minus mu become sigma, that is become Z now. New variable, then x also change to Z now. See the change different here? F is a d equal 1 upon 2 pi square root of 2 pi exponential minus z squared by 2. Now you can put the x instead of z, but normally we are not putting x because we have converting this one assuming mean is 0. Remember, this is normal distribution table can be applied for any situation. It can be IQ situation, it can be a mark situation, it can be the some maybe the another maybe another variable industrial application, right? Industrial application, the variable maybe the diameter of the component, maybe the length of the component manufactured from the automated process. Likewise, any variable can be a dimension, it can be a diameter, it can be a height, it can be a maybe age sometimes, different kind of variable. The different situations actually we cannot have the common table. So what we can do is we convert the normal distribution to standard normal. This is the what the purpose here to apply any situation. Remember, to apply any situation. I can remember when I explained this particular one for the BST student yesterday. They are actually very good because they are all done A level. They are all done A levels. They are very good passes in the first semester. All maybe almost all get A grades. So one student asked very interesting question: why you are using the standard normal rather than using the normal distribution? Right? That's a logical question because how we if you have the normal distribution like mu and sigma, this one because it depends on the variable height, weight, age, IQ, whatever. We can use the common table to calculation purposes. Very difficult. We have to convert, the variable independent measure. That's the standard normal distribution. These, theoretical concept may be little bit abstract, but actually the whole final calculation actually you are supposed to understand are very simple. Now see the one we are talking about. When mu is 0, I think you can understand that, no? When mu is 0, x minus 0, 1. X minus 0 divided by 1. That is simple x, no? Same. Z equal x. Actually, we are leaving the variable, change the variable. Based on this particular value, x becomes z. Now this is the what we call standard normal distribution. Remember, if you draw this particular curve in mathematics, you don't have adequate knowledge to draw this particular graph. That is not the like a parabola or whatever. It's a bell-shaped curve. Mu becomes 0, sigma becomes 1. Now you see the graph in the next slide. See the graph now. This is the perfect graph. This has been actually taken from the internet. It's very smooth graph. See the equation f z equal 1 upon square root of 2 by exponential e to the power z squared by 2. Maybe if you the familiar way, maybe fx equal this number exponential x squared by 2. If you draw this particular graph, it's this kind of bell, symmetrical bell shape. You see the almost all the values are in between minus 3.4 and 3.4. If you have the tables printed yourself, you can notice that. Remember, that's what I asked you. In the email also I put that. No, I have a hard copy of this normal distribution table. If you want to learn, you have to have the hard copies. But I don't know how to do the exercise. I think you can't do any exercise without the table, but I can explain because I have copied some table, copy the PowerPoint slides here. I can explain the concept. See, if you see the table here, after minus 4 is nothing. Only the curve part will be here. See, the minus 3.4 to plus 3.4. The entire table will be finished. And the area, of course, in another, see at the top of the one, this is the what we call the kind of probability distribution. Remember, probability distribution because area minus infinity to plus infinity is a 1. You can understand this thing because you have not done integration yet. No, this integration give the area. minus infinity to plus infinity to this integration will give this particular area under the curve. Remember, area under the curve, that is 1. So this can be used as a probability density function. In example, you need not to understand that complex mathematics shown here, but the simple thing try to understand, right? And go to the next one. This is now when you convert to normal distribution. See that x minus sigma x plus sigma become minus 1 plus 1. Can you see? If you can't understand that, take a piece of right. See what is mu minus sigma. When mu is 0, sigma is minus 1. Sigma is 1. That is minus 1. No? X minus sigma, mu minus sigma become minus 1. What is the mu plus sigma? Mu is 0, sigma is 1, plus 1. You can see that's what the mu minus sigma, mu plus sigma range become minus 1 and plus 1. Now you can understand very easily normal distribution table you see here. Minus 1 plus 1, 68% of the data now. This is based on the standard normal curve, remember. Based on the standard normal curve, these were 16% of the data, IQ, so whatever, become a minus 1 and plus 1. Minus 1 and plus 1. Then minus 2 and plus 2, 95%. Minus 3 and plus 3, 99.7 area. I think now it is using the table. There's a particular table has been prepared. This is the normal distribution table. See, if you have the hard copies with you, you can understand it's the 2 pages. One page from minus 3.4 to 0. See here. In this mode, then you can easily see, I think the page is shared. No? If I open the what you call the PowerPoint show mode, I think you can see this is the table. This is actually part of the table. This is not the entire table because see the 0 to 0.7, then it start 2.3 to 3.4 because some portion, some part in the middle has been removed. Otherwise, I can't place the entire table on the PowerPoint slide. You understand? I can't put all the table values on the PowerPoint slide because width is limited. No, I just put 0 to 7. Other values are there. Remember, other values. So then start 2.3 to 3.4. I just want to show start and end. In between there are many values are there. Remember, 1 point, 2 point, 3 point. All the values are there. The other side. So we have to go back to the previous 2 slides. Because sometimes the PowerPoint is not responding, that's the problem. This is the positive part, right? And this is the negative, just open the. Now see the minus 3.4 to 0. See, minus 3.4 to 0, the other side, other part. See the graph also here, can you understand? 0 here, 0 at the middle. Far left side, minus 3.4. Here, 0 to 3.4. Other table, 0 to plus 3.4. This is 0 to 3.4. See, these are the 2 tables. Actually, 1 table with the 2 pages we require for the calculations. Right? Now, I think before that we have to go for some other slide. We missed that particular slide. This one. See the slide now. Now, frequently, actually, we'll be able to calculate the probabilities first. Remember, now we have done probabilities, no? We have to calculate the entire probability is 1. Remember, entire probability is 1 because under the curve area is 1. The area can be used as a probability now. If you want to evaluate this kind of thing in using tables, Just understand immediately. That's all. In the example, you can understand easily. Just try to understand what I am telling. To evaluate this X variable. See that this is the distribution of maybe height, IQ, or whatever, right? Maybe height distribution, maybe any variable dimension, diameter, length, whatever. This is our normal distribution X, right? This is the converted normal is a standard normal. The top one distribute is specified in the diagonal slide. See? Not maybe in the other slide to tell display. I see distribution of this is a distribution of X. It's a distribution of Z. This is the normal practical example. Now, for example, the marks between, suppose X is a marks, think about now in this way. Marks between 30 and 70, likewise. Probability of marks between 30 and 70. Maybe 40 and 60, likewise. Marks. But we cannot use with the variable marks. We have to convert to Z. Whatever the variable, maybe marks or the IQ, maybe the diameter or the length, maybe the age. We have to convert to the standard normal, Z this scale. Then only the table can be used. I think you'll be able to understand now, right? What is the mechanism? We change this X variable to standard normal Z. Z means, see here, if you want to change A to the normal scale, Z that A become Z1 now. What is the difference? A minus mu by sigma. That you get Z1. Z2 will be given B minus mu by sigma. And mu and sigma is the standard deviation and the mean and the standard deviation. Now you see this probability A less than X less than B become probability Z1 less than Z2. Now you can use the table. I just explain the part by part how to use the tables. And these are the tables we saw earlier. Now see, I think from that onwards we can use the PowerPoint slow because I just want to enlarge the screen. See how to calculate the Z less than 2.2. Right? We want to calculate the diagram. See at the right hand side, to simplify this thing, I have actually draw the normal curve in a different software. I bring it here. See the normal distribution curve with the 2.2 mark here. Right? 2.2 mark here. Less than 2.2 is specified in shaded color. See, in ash color, less than 2.2 is shaded here. Entire probability is 1. Remember, entire shaded area is 1. The table, as we see, the table values are 0.5, 0.9, or decimal values because the maximum value you can have 1. That means probability minus 3.4 to 3 plus 4. Now read how to read the table. Less than is at 2.2 is the see the table here. See, just a red arrow is specified. 2.2 just first 0. And these other the 0, 5, 0, 6 are used for the when you have the value 2.27, 28 likewise. You have only 2.2 practice initially. Read this particular value. Less than is at less than 2.2 mean 9861. Then you can say therefore the probability less than 2.2 is a 9861. Later we'll explain how to use this one for the practical problem. Right? First I try to understand from these slides, maybe 5 or 6 slides are there, how to read the table. See now if you have the table, now you can understand how useful these things. You can understand by looking at the screen, the table copies that been put at, I put it here. I cut and paste some parts of the table, then you can understand. You have to learn, you have to follow the instruction given. Even though you have the software, you cannot open it now. But yeah, if you can open in different way of two computers, you can do that, right? How to read the Z less than to 1.26. Now this is the case where you have to use this values also other column. 1.2 has to be read from the last column, first column. See, you said 1.2 and 1.26 means 06. Part has to be read from this column. Remember, this is a globally used, very popular tables. Any student supposed to do any higher education, higher studies, these tables have been used. Not only the any whatever the subject independent theories. Remember, these are subject independent theories normally used in a research. Right, when you conduct some research, this kind of probability calculation everywhere involved. Now see the point value 9.8962, right? 0.8962. This is how you can actually read the value, right? 0.8962. Every time remember, it said less than 1.26, just read the table. Because the table shows every time the left hand area, right? Now left hand area 0.89, earlier example 2.2, no? 2.2 we get higher with higher value than this, no? Likewise. If you take the less than 0, tell me if you can answer that question. What is it said less than 0 value? From the table, from the diagram, you can understand. What should be the value? Is said less than 0? I said mention the entire part is 1, remember. Entire area is 1. Less than 0? What should be the value? Less than 0? 0.5, no? Exactly 0.5. If you have the table, you can check. You don't have table, no? If you have the table, you can check. Less than 0 means, is said less than, if you have, is said less than, if you took 0 here, instead of 1.26, you put 0 here, then you have to take the, is said less than 0. See the table here, see? And it is interesting. See the table? It said, when it said 0, what is the value? Can you see the screen? 0.5. Because both sides are symmetrical. 0.5, 0.5, that will be the 1. The logical thing, just try to understand, right? The previous day, some student actually give some answers. Now nobody given answers. Okay, you read the minus value. Is that less than? First, try to understand the table, right? Otherwise, you can't do anything. See how effort has been made to teach this kind of thing. Just use the Flash software to draw this graph. The PowerPoint cannot be drawn. This kind of thing. Just draw this graph and see the minus 1.57. It's a point this here, minus 1.57 here. Remember, table values every time in between minus 3.4 and 3.4. It won't go beyond this range, because almost all data of the normal distribution, standard normal distribution, are in between this particular extreme ends, minus 3.4 and plus 3.4. Right? Now read the table, read how to read the table. It said minus, now we have to go to the minus side of the paper. See, minus value is minus 1.5 here, this is minus 1.5, and see the red arrow here, 0.0582. Everything is, you can, by looking at, you can understand. If you have the common sense, that's all. Now, how to calculate this kind of thing? Is it greater than 2.25? The required area probability is shaded in the graph. See, this greater than, no? Earlier less than left side. Greater than means this particular side. Remember, table every time show the left hand area calculation. Try to understand what I am telling now. You want to calculate, is it greater than 2.25, this area. The table give the left hand side area. To get the right hand side area, read the 2.25 from the table. See, read the 2.25. See, 2.2 here, 2.259878 table value. But you require greater than this area will be given by 1 minus the table reading. 1 minus table reading. With the common sense, you can understand 0, 1, 2, 2. Notice the table gives left hand side area the entire area is 1. You have to understand this also. Now I explain or notice that table gives the left-hand side area every time. Left-hand side area. If you want to calculate greater than values, you have to do in this using this mechanism 1 minus the table reading. Another example 1 minus is greater than 1 minus 1.73. So the big area now, the big area now. Minus because minus 1 this side. Greater than is right hand side. A table minus 1.73 give the left hand area again. If you want to get the right hand side area, 1 minus again. 1 minus, what is the minus 1.73? Is the value 0.18. 1 minus 0.18. The shaded area is 9582. Big area is 9582. Then you have to understand how to calculate the kind of range, this range. That is area in between these two values. Because to simplify the answer, I just have the 3 diagrams. Observe the first diagram, top diagram first. Top diagram first. Is said in between minus 2.58, 1.13, right? Minus 2.58, 1.13, right? Now, how to get this value? This is simple than the greater than, because you know that if you read the 1.13, see the second diagram now. If you see the 1.13, it will show the left hand side area table. If you read the 2.58 minus 2.5, it shows that this particular shaded area left hand side. We want to this particular shaded area, first diagram, no? Just take the difference, that is all. Read the 1.13 value minus, read the 2.25 minus 2.58 value. Then it will give this in between area. See the probability. First read the value 1.13 from the table, that is 0.808. It's here. Now read the minus 2.58, that is 0.049 table reading. Actually, two sides have been copied, right? One is positive side, one is negative side. You can see the two portions. This is not the one table. Remember, you can't see the these two portions in the very closely like this, because I just copied the two portions from the tables. Remember, two portions from the positive table, one negative table, one portion. Then only we combine this diagram here. Then take the difference. Then take the difference. 0.7708 minus 0.9. Then you get the required probability here. The diagram shows in the first. I think that's enough, the reading table. If you don't have the table, I don't know what to do. If you are not doing your part, what can I do? What can I do? I can stop everything, right? That's the thing I can do. That's the delay in getting the degree yourself. I don't know. I don't like even to continue in this pattern. I just complain to the university, maybe the coordinator, Mr. Vijayadran, coordinating the second semester. Because see the number of students. Only 11 now. Earlier about 15, 14. Only 11 joined today. There are many students left now. How can they learn? The problem, this corona problem is getting worse, right? That means, the face-to-face session, even we can't expect to start any soon. See, the university open, I don't know what to do. Unless you have continue in this session. I don't like to continue, this session with few students. Again, I don't like to start the calculus part with few students. What about the other students? What to do? If you have any comment, just switch on your microphone and tell me, because what is the problem with the other students? Even the link is provide free. When the link is provide free, Why others are not attending? One student say they cost the link. They just running through the learn. Running through the learn, of course, the link should be free. No? What about your comments? Are you cost the data? You have to pay for the data? It costs for the data. I think it is running through the learn. The connection should be free. If you don't have a free connection, talk to the university. That is not my duty to work on that. No. You see, in my side, no problem because no barriers, 40 minutes barrier. Straight away you can, because before I go ahead, I think I just want to clarify those matters with you. Whether you want to continue in this fashion, no, those close it. I can easily close. I don't like, even I did not to obey the university rules, right? I have been conducting lectures and no longer I'm in the permanent staff in the university. Actually, I doing this for the sake of the student. If you don't want to follow those things, I can easily, I can do my other things. What is the problem? If you have a problem, please say me email me. Sinhala, ඔයගොල්ලෝ ප්‍රශ්නයක් තියෙනවා කියන්න මොකද්ද තියෙන problem එක මේක? You can understand only 12 participants participating out of how many? 120 selected, no? 40 by 3. 40 by 120 original group size. Mr. Patran says last time they selected 40 for one group. It is 120, right? Maybe 120, maybe at least 90 should be there, no? At least 90 should be there. There's අනුවක්ක තඩු ගන්න ඉන්නේ පෑදැන්. You have to open discuss. ඔයගොල්ලෝ open මේක ගැන කතා කරන්න නැතු මේක තේරුමක් නැහැ මේ වැඩේ. ඔයගොල්ලෝ තේරෙනවා දැන් මේ කොච්චර effort එකක් දරන්නවද අපි මේක කරනවා නම් online කරනවට. ඔයගොල්ලෝ තේරෙනවා මේ material හදන්න ලේසිද? ඒක subject එක අනිවාර්ය subject කියනවා course එක කරනවට කරන්නවට. The part-time students actually they are attending classes. Even they are employed. ඔයගොල්ලන්ට තියෙන ප්‍රශ්න දිනම් කියන්නේ මොකද අනිත්‍යගේ මේ ප්‍රශ්න මොකද මේක අපි කන්ටිනියු කරනවද නැද්ද කියලා you have to tell me. The microphone is my speaker is on. I think that is I just increase the volume if you want to say something because I don't like to continue in this fashion, right? If you have a problem, any problem, what about the other problem? Please, it cost. Okay, ඔයගොල්ලෝ පොඩ්ඩක් කතා කරලා මට කියන්න. මොකක්ද ඉක්මනට කියන්න දැන් you can switch on your microphone and communicate, no? Probably why you are not communicating with me because I can remember that yesterday we had the class with the BS2 students. Every time they communicate with me, if they can understand me, if you want to explain anything any further, they talk to me very closely. What is the problem with you? ඔයගොල්ලන්ගේ මොකක්ද ප්‍රශ්නයක් තියෙන ඉක්මනට කියන මේ ස්ලයිඩ් එකෙන් යහට යනක otherwise I just close it, right? මේක ස්ටොප් කරලා දාන්න නිකන් ඉන්නවා මට මේක කන්ටිනියු කරන්න ඕන කමක් නැහැ කොහොමවත් මට තියගන්න. I just continue the prepare ඔයගොල්ලෝ තේරෙන මේ material හදන්න කොච්චර මාසෙ වෙනවද mathematics වල ඔයගොල්ලෝ දන්නවා equation editors පාවිච්චි කරන ඔක්කොම complex work normal ඔයගොල්ලෝ සයිඩ් එක මොනවද කියන දේ තියෙන ඉක්මනට කියන්න මට. දැන් මේම ළමයි ටික දෙනෙක් එක්ක මේක කරන එකේ තේරුම නැහැ මගේ effort එකත් අපරාධනේ. මට වෙනක් කරන්න තියෙන වෙලාවනේ මේක මේ මම
සර්
යෝ කියන්නේ
එහෙම මොකද ප්‍රශ්නයක් නම් නැහැ සර්. ඒ කියන්නේ සර් ගණනය එහෙම ප්‍රශ්නයක් නැහැ. මේ ඒ කියන්නේ ගොඩ දෙනෙක් මම දන්නේ නැහැ සමහරට කනෙක්ෂන් නැතුවද කියලා මේ අපේ දැන් අර WhatsApp group එකක් එහෙමත් තියෙනවා ළමයි ඔක්කොම ඉන්න.
ඔව්.
මේ ඒකේ වුණත් සර් මේ දැන් ලෙක්චර්ස් එන 13 14 ඒ වගේ ප්‍රමාණයක් තමයි සර් කතා කරන්නේ. ඊටු ටික මේ මුකුත්ම විස්තරයක් නැහැ.
හැම කෝස් එකෙම තියෙන මේ ප්‍රශ්න දැන් බැච් 1 එකේ ඊට වඩා වැඩි ඇටෙන්ඩන්ස් ඊට වඩා ටිකක් එනවා. ඒ වුණත් ඉතින් ටෝටල් ගායක බැලුවා සංඛ්‍යාව බැලුවොත් එහෙම බොහොම අඩු percentage එකක් තමයි දැන් මට සමහර ලෙක්චර්ස් කියනවා මේ ඒගොල්ලන්ගේ තමයි ඉංග්‍රීසි වලට ආරෙන්නේ සමහර සෙෂන් වලට ළමයි එක්කෙනයි දෙන්නයි.
අපෙත් එහෙම තමයි සර්. ඉංග්‍රීසි වලට ළමයි ඇත්තම නැති තරම්.
ඔය එක තමයි ඉතින් මේ අපි මේ දරන එෆර්ට් එක දැන් ඔයගොල්ලෝ තේරෙනවා මේව හදන්න කොච්චර මහන්සි වෙනවද කියලා. දැන් මේ මැටීරියල් හදන්න දැන් මෙච්චර මේ සිම්පල් මොකද මේවා ෆේස් ටු ෆේස් එක්ස්ප්ලেইন කරනවා නෙමෙයිනේ. මේක මැටීරියල් එක පුළුවන් තරම සිම්ප්ලිෆයි කර කර හදන්නවා. මේක ඇත්ත වශයෙන්ම මාස 3ක් විතර ගියා මේ සබ්ජෙක්ට් මේක විතර නෙමෙයි මම වගේ PowerPoint slide මට 60 ගාණක් සබ්ජෙක්ට්ස් එක එක ඉයර්ස් වල සමහර දැන් සමහර ඉයර්ස් වලට ඩියෝත් කරනවනේ අපි. ඉතින් ඒවට උගන්වන්න ගියාම සෑහෙන අමාරුයි. මොකද කම්ප්ලෙක්ස් ඉක්වේෂන් කවයි ඩීටේල්ස් වලින් එක ස්ලයිඩ් එකක් හදන්න යන සමහරවිට විනාඩි 30ක් 40ක් විතර වගේ. එච්චර අමාරුයි මේක කරන්න. ඉතින් මේක එච්චර එෆර්ට් එකක් දාලා මේවා හදුවට මේක ප්‍රයෝජන ගන්න නැත්නම් මේ ළමයි ඉතින් අපිට ඉතින් නවත දාලා තමයි නිකන් ඉන්නේ. මම දැන් මේකම යුනිවර්සිටි මම ඔයගොල්ලන්ගේ කෝඩිනේටර්ට කතා කරලා කීප සැරයක් කියලා තිනවා මේ කෝඩිනේටර් කියන්නේ ළමයි ඉන්න ප්‍රමාණයට කරන්න. එහෙම තමයි ඒගොල්ලෝ කියන්නේ. ඉතින් මම කටහඬින් ඔයාමට අතුරුතය කවුද කියලා නිතරම කතා කරන එක්කෙනෙක්නේ. තමයි ප්‍රශ්නේ. මේ සමහරුන්ගේ මැතමැටික්ස් නොලෙජ් එක බිඳුව තියෙන අයට මට හෙල්ප් කරන්න බෑ. මොකද සිලබස් එක කරන්න බෑ. මම normal distribution මෙච්චර සිම්පල් විදිහට කොහොක්වත් යුනිවර්සිටි ලෙවල් එකේ ගිහිල්ලා බලන්න කොහොමද උගන්වන්නේ කියලා. ඔයගොල්ලන්ට මොකක්වත් තේරෙන්න ගන්න නැහැ ඒතකොට. මේ අපි පුළුවන් තරම් සිම්පල් විදිහට තමයි මේක කරන්නේ. මේ පාර්ටිසිපන්ට් සංඛ්‍යාව අඩු වෙන එක තමයි මේ ප්‍රොබ්ලම් එක තියෙන්නේ. ඔයගොල්ලෝ කැමති නම් මට දැන් මේක කන්ටිනියු කරන්න පුළුවන්. මේ එක්සර්සයිස් ඔයගොල්ලන් දැන් පොඩ්ඩක් කියන්න ඔයගොල්ලන්ට මේකේ ටේබල් එකේ කොපියක් නැතිද හાર્ඩ් කොපි එකක්?
හાર્ඩ් කොපි එකක් නැහැ සර්. ඒ වුණාට සොෆ්ට් කොපි එක බලා ගන්න පුළුවන්.
හැමෝටම බලා ගන්න පුළුවන් සොෆ්ට් කොපි එක.
අනිත් කට්ටිය ඉතින් කියන්නේ නැහැනේ සර් ඒකනේ. මොකද
කතා කරන්නේ කවුරුත් කතා කරන්නේ නැහැ නේද? දැන් සමහර part time ස්ටුඩන්ට්ලා ඊයේ BST semester 2 එකේ engineering mathematics 2 module එකක් කරා. ඒ ළමයි කතා කරන හැමෝම කතා කරන තැනිතරේ මං කිව්වොත් හැමෝලට එකට ගොඩක් කතා කරන මං කිව්ව ඒක පාරට එක්කෙනෙක් කතා කරන්න කියලා. ඒගොල්ලෝ ගොඩක් නිතරම මාත් එක්ක කොමියුනිකේට් කරගෙන තමයි මේක කරේ. මොකද ඒක එම වුණොත් තමයි මේක සාක්ෂස් වෙන්නේ. නේද? මම නිකන් මෙතන දේශනය කරන් කියලා මම දන්නේ නැහැ ඔයගොල්ලෝ නම් තේරෙනවද නැද්ද මොකද කියලා ඔය පැත්තෙන් මොකක් හරි ෆීඩ්බැක් එකක් තියෙනවා හැමදෙස්සෙම. එහෙම නැත්නම් මේක සාර්ථක වෙන්නේ නැහැ. මේ ඕන්ලයින් ඩිලිවරි කරනවා නම් ඒ වගේ ඔක්කොම අනිත් ඒවාත් තියෙනවා. ඔයගොල්ලන්ට කනෙක්ෂන් එක කොස්ට් වෙනවද නෑ නේද?
අද සර් ඒ වුණාට මේ කැපිලානේ ඩේටා.
එහෙනම් බලදායිද?
ඕ.
ඒ ඔය ට්‍රාන්ස්ෆර්නේ කිසිම ක්ලාස්
MB 300ක් විතර කැපිලා තියෙනවා සර්.
ඒ කොහොමද වෙන්නේ? ඉතින් මේ Zoom එකෙන් කනෙක්ෂන් ෆ්‍රී කියලා තමයි දීලා තියෙන්නේ. මම දැන් මට මම දන්නේ නැහැ මගෙන් කොස්ට් වෙනවද නැද්ද කියලා. මොකද මගේ තියෙන්නේ මේ අන්ලිමිටඩ් කනෙක්ෂන් එකක් තියෙන්නේ. අපි මේක අවුරුදු 10කට විතර කලින් ගත්ත එකක්. දැන් ෆැසිලිටිස් මේ අන්ලිමිටඩ් ෆයිබර් ඔප්ටික් කනෙක්ෂන් දැන් දෙන්නේ නැහැ. අලුතෙන් දෙනකොට ලොකු කොස්ට් එකක් වෙනවා. අපිට මාසෙට රුපියල් 900 ගානයි මේ කොච්චර පාවිච්චි කරලා කියන්නේ. ඉතින් මට ඒක දැන් මට මේක කොස්ට් වෙනවද කියලා මට තේරෙන්නේ නැහැ කොහොමද බලන්නවත් ඇත්තට.
මට හිතෙන්නේ සර් මේ දැන් අර සර් අපිට යූසර් නේම් එක නෙවන්නේ. ඒ කියන්නේ අපි එතකොට Zoom එකට ගිහිල්ලානේ ලොග් වෙන්නේ. ඒ නිසාද දන්නේ. ඒ කියන්නේ අර අනිත්
ඔයගොල්ලෝ ඔයගොල්ලෝ ලොග් වෙන්න ඕන ලර්න් එක හරහා. ඔයගොල්ලෝ දැන් යුනිවර්සිටි එකෙන් ඔයගොල්ලන්ට මේ ලර්න් එක හරහා යූසර් නේම් පාස්වර්ඩ් දීලා නැද්ද?
එකක ඔපරේටින් සිස්ටම්ස් ලෙක්චර් එකට අපි account එකක් හැදුවා. රෙජිස්ටර් වෙලා. අනිත් ඒවාට සර් මේ අපි account හැදුවේ නැහැ මේ ඒ දැන් අපේ අනිත් lecturers-ලා email එකේම මේ ඒ learn එකට තියෙන link එක එවනවා. ඒක click කරන්න විතරයි තියෙන්නේ.
මම මොකක් හරි ප්‍රශ්නයක් දැන් මම මේක පොඩ්ඩක් කෝඩිනේටර්ස් එක්ක කතා කරලා බලන්න. මම දැන් මේක ඉතින් මේ ටෙක්නොලොජි එකට අපිට අලුත් මේක මේ අපි මේකෙන් කරේ නෑනේ කලින්. ඉතින් කෝඩිනේටර්ස් එක්ක බලනවා දැන් මම කෙලිම මට යූසර් නේම් පාස්වර්ඩ් දීලා තියෙන එකෙන් කෙලිම ඉන්ටර්නෙට් එකෙන්ම තමයි කනෙක්ට් වෙන්නේ. කෙලිම ඉන්ස්ටෝල් කරපු software එක පාවිච්චි කරන්නේ නෑ. ඉන්ටර්නෙට් එකෙන් ලොගින් වෙලා යූසර්
දන්නේ කොහොමද කියලා මේ හිතා
එහෙම ගිහිල්ලා තමයි මම ලොග් වෙන්නේ. මම ඔයගලන්ට ඒතකොට මම ඒවල තියෙන්නේ මීටින් ID එක. මං හිතන්නේ ඒක තමයි ප්‍රොබ්ලම් එක වෙන්නේ. මං හිතන්නේ ඔයගොල්ලන්ට මේ අර ලින්ක් එක මම යවලා ක්ලික් කළොත් මං ඉතින් ෆ්‍රී කොස්ට් වෙන්නේ. අනික පොඩ්ඩක් චෙක් කරලා බලන්න. කොහොමද මේ ලින්ක් එක ඔයගොල්ලන්ට යවන්නේ? එහෙම කරා නම් මං හිතන්නේ අපි next week එකේ ඉඳන් try කරලා බලන්න. මං හිතන්නේ ඒක ඔප්ෂන් එකක් තියෙනවා ඉන්ටර්නෙට් එකේ කනෙක්ට් කරනකොට ඔයගොල්ලන්ට ලින්ක් එක කොපි කරන්න මොකක්ද එකක් තියෙනවා. මම දැන් මේ කරන්නේ විදිහට සමානට question එකක් දැන් නෑ මොකද මේ මම ඔයගලන්ට ඉවල තියන්නේ meeting ID එකනේ.
ඔව් සර් ID එකෙන් අපි එතකොට ID එක zoom එකේ මම නම් ගියා zoom එකේ අනිත් අය නම්
තමයි ඔයිට ID එක ගාලා ගත්තාම සමහරට ඔයගලන්ට data cost වෙනවා. දැන් මට සමහර data cost නොවෙනවා ඇති. මම දන්නේ ඒක මට cost වෙනව නැතිල මට ඒක ඉතින් ප්‍රශ්නයක් නෑ cost උනා. මේ ප්‍රශ්නේ තියෙන්නේ මේ මම පොඩ්ඩක් check කළා මේ විජයවර්ධනත් එක්ක කතා කරලා බලන්න මේ zoom එකෙන් ඔය learn හරහා කරන්න මේ first week එකනේ. දැන් අද තමයි ඒක අවසන් වෙන්නේ. Friday ඉඳන් මම කරා. අදින් අවසන් ආයි ලබන Friday තමයි ඊට කලින් මේ ඊළඟ lesson පටන් ගන්න කලින් මම පොඩ්ඩක් නිතු විජයවර්ධනත් එක්ක කතා කරලා බලන්නම් එහෙම link එක ඒ විදිහට යවන්න. එතකොට ඔයගලන්ට කෙලින්ම link එක click කරලා ගත්තාම හරි නේද?
ඔව් සර් ඔව්.
ඒ link එක click කරලා join කරනවා නම් හරි. මොකද මේ pass මේ meeting ID click කළාම ඔයගලන්ට data cost එක එන්නේ නැති. ඔය කියන්නේ හරි. දැන් මට තේරුණා ඒක. මම login වලට බලන්නම් ඒක අමුතුවෙන් schedule ඊළඟ set class වල schedule හදනකොට ඒක කරලා බලමු. අපි මේක මේ section එක කරලා අපි ඉවර කරලා දාමු. data cost එක නම් ඔයගලන්ට අපි next week ඉඳන් බලමු මේ විදිහට මේ කරන්න. අපි දැනට එන මේක continue කරමු දැන් ඔය ළමයි ටික දෙනෙක් එක්ක right?
හරි සර්.
Right. Now, this I don't know you can understand how to read the tables in different manner. You know, the first thing is that less than values. If it is less than value, directly you can read the value from the table. Is a greater than value, you have to take the 1 minus table value. Third category is this one. If it is given by a range like that, the second reading minus first reading. එහෙම තමයි දැන් ගන්න ඕනේ. second reading එකෙන් first reading එක අඩු කරනවා. ඔයගොල්ලෝ logic එකේ පේනවා මෙතන first reading කියන්නේ 1.13 in left hand side reading. 3.2 minus 2.58 is less than reading. So take the difference, then you get the first table required area, right? I will not be able to convert in a single because there are maybe some time usement students follow. So, okay, you go to the next slide. I think you see some example. So this is example. Remember, you have to understand only this kind of example. You know, whatever the situation, your calculation is nothing. See, very simple calculation has to be performed. See the example. Okay, examples are important. See the marks of 2,000 students in an examination. From a normal distribution that is given, right? The distribution of the 2,000 students marks is from a normal distribution. Only thing you see here, we don't know actually any marks. There are actually 2,000 marks are there, but we don't know the marks, but the two parameters are given. Mean is 52 and standard deviation is 10. Every time, whatever the population, these two parameters has to be given. Mean value is 52, the standard deviation is 10. And how many now we have to find out answers to this kind of simple question. How many students had marks? Remember, we don't have the mark, but we can actually forecast. We can actually calculate this kind of thing using normal distribution. Now you can understand how useful this particular kind of the table for even industrial application also. This is some simple examination for the marks, education case, right? How many students had marks? First part greater than 75. You want to calculate how many students were there had marks greater than 75, right? Likewise, then greater than 40, less than 65. How many students? How many students obtain marks between 40 and 60? You can easily calculate. Just take the first part here. See that just want to get maybe the pointer so you can sometimes you can't see the what you call the mouse pointer. You difficult to see. Just do it again. You just want to get the laser pointer so you can see the see the laser pointer. You can see easily. See that first part, the marks greater than 5. The variable is marks. Remember here, let marks is the variable. Initial variable is normal variable, not the Z. That's the thing you have to understand. You have to calculate. Calculate is probability first. Remember, we calculate what is the probability of the mark, the any student marks is greater than 75. This has to be converted to the Z score. To conversion procedure is this one. Z is x minus mu by sigma. Now this is the Z score, x minus 52 by 10, because mu given as a 52, sigma is given 10. Now how to see how to convert the to the Z x greater than 75 to Z score. So x, if you convert x to Z, x minus 52 by 10. If it is 75, 75 minus 53, x is our mark, mean divided by 10. This part can be simplified. No? Left hand side is a Z, x minus 52 by 10 means Z score, Z score. Greater than 2.3, 75 minus 52 by 10 means simplify 2.3. Now we have to use the table 2.3. Remember, if you have this particular Z minus x minus mu by sigma, every time you get values in between minus 3.4 and plus 3.4. It was not going beyond that particular range unless, you know, the distribution, in that case, if you get a value, you know, that past the extreme means, and then the value is not normally distributed, remember. Is it greater than 2.3? That is 1 minus, remember, 1 minus the reading. If you read the table now, 2.3, if you have the table, so if you have hard copy, just read the Z, what is the Z 2.3. I have the hard copy, right? I have the hard copy. If you read the positive, the plus side 2.3, 2.3 in the first column, now 2.3, you see the 9893, 9893. If it is a greater than, mean 1 minus, and that means 0.10. So that's the probability of the having student mark greater than 75. Remember this logic behind here. If the probability calculate, we know the total number of students, no, 2000. Multiply this probability by 2000, then you get the number of students. Now we are calculating the other way. Earlier we did the, if you know the certain frequencies, we calculate the probability by dividing by 2000. No? If you know the probability, you can multiply the number of students here. You get the 21. See 21. Actually, what is the 21? Out of 2000 students, only 21 get the marks greater than 75, based on this normal standard deviation and the mean value given here. That's how we, do the first part. Second part, say, see the x greater than 40. Now this is a different slide, right? In question also is still here. Greater than 40. See. Now, if you see the different example, you'll be able to understand really what it is. Greater than 40, Z convert to Z score, x minus 52 by 10 again, same. But 40 is a different now, x minus 52 by 10. Now here 40 minus 52, x minus 452 by 10. Left hand side is a Z greater than minus 1.2. 40 minus 52 by 10 means 1 minus 1.2. Now read the table. If you have the table minus side, 1 minus 1.2. Even the first column. No? Yes, any question?
No, right, sir.
Minus 1.2, table value, see 1151. The table actually values all decimal, right? 1151. This is a greater than, no? So we have to 1 minus 1151, that's 8849. Yeah, that's high probability. Remember, high probability. Marks having greater than 40, it has a 40 means the small mark, no? Greater than 40, high probability. So multiply that probability by 2000, you get 1770. Based on this information, we can actually assume approximately out of 2000 students, 1770 students obtain marks greater than 40. Actually, this number of marks, 1770 marks out of 200 marks are actually greater than 40. Value is greater than 40. So similarly, you can calculate the other one also. Less than 65, actually correct. Directly you can read the table, right? And this time, he said less than 65 minus 52 by 10, that he said less than 1.3. He said less than 1.3. See the plus side 1.3, 9032, 9032 table value. Right? He said less than, no, every time the table value will give the probability. Multiply 2000. In this case, we are handling the 2000 marks. No? So we get the 1806. Student get marks less than 65. So similarly, you can get that range also. And then finally ask, how many number of students get the marks? 40 and 60. 40 and 60. To get this particular range, now we have to have this particular range. See? 40 less than x less than 40. Convert to Z. 40 minus 52 by 10. Middle part is of course Z. 60 minus 52 by Z is minus 1.2, 0.8. What is the calculation here? Read the 0.8 value, 0.8 value, 778, and minus other value, minus 1.2, minus 11, mistake here, point, right? 0.1151. Remember, it's not the 1150, it should be 0.1151. The dot is missing. 0.673, that's the probability. Actually, every time we calculate the probability, then multiply by that number by 2000, you get the 1346 number of students obtain marks between 60 and 40 and 60. You know that we can get answers that kind of thing using the normal distribution. If it comes to the industrial application, I think there are some industrial application also next to see. You know, the arrows are not working because of the that means, but arrows can be changed sometimes. Arrows doesn't work. Very arrows of work. Just cancel the laser pointer. Laser pointer is the mouse is not working when you do the laser pointer. So we go for the next slide. Now see the this is industrial application. Now you can understand, you know, if you see I very slowly explain this industrial application, how useful this kind of normal distribution table, you know, the quality control and all that in industry. See the first example, articles are produced. Article name is not given, whatever, right? Maybe bearing, maybe any bolt or nut or whatever. Automated process, right? Manufactured by automated machines. Articles are produced with the dimension. Dimension may be the length, diameter, or height, or whatever. Maybe width, whose mean is given 114.92 millimeters. Remember, article has been producing with mean value. If you calculate the mean value and standard deviation, it will show that part. Now try to understand what this mean. How to calculate the company this kind of thing. Remember now, particular machine is set to produce that particular component, the article, a certain dimension, Now, if you want to calculate the mean dimension and the standard deviation, you have to get maybe large number of samples, right? We take maybe 1,000 samples. One day we can take 1,000 samples and measure all the values, 1,000 values, and calculate the mean value and get the standard deviation also. You know, first semester we have done how to calculate the mean and the standard deviation. No? Similarly, you can calculate, you know, the mean and the standard deviation. These values have been taken, you know, from the results of particular survey. Remember, so therefore they have some, you know, the benchmark, what we call, when they produce this particular article, the mean dimension should be 114.92. This is maybe the requirement. Maybe actually, you know, maybe the actual size may be 150 millimeters sometimes, right? The machine originally has to be set to produce item with diameter or length, whatever, 150 millimeters. But actually, if you take the mean value by observing many items, that may be slightly different, 114.92 millimeter as a mean. Standard deviation is a very small number, 0.15. Zero is very small man. You know the length of the millimeter, no? Millimeter 0.15 mean very small dimension. Normally, you have to have the special tools to measure, you know, to see this kind of precision, right? Now that part you can understand. No? The articles has produced with the dimension whose mean is 114.92. That's the required value. Remember, it should be actually the actual value maybe 114, but when we measure the mean value given in this one, the standard deviation also given. But in this next sentence, if the tolerance limits are 114.959 and 115.1 millimeter, observe this two extreme ends value with the mean. I just want to clarify this question, a little bit and to understand very clearly. See the mean value. Mean value should be 114.92. What is this first value? 114.59. That is less than the mean, no? That is less than 114.59. If you consider the other value, 115.15, the big greater than that particular mean value, right? What the tolerance limits mean? If you take any item from the production line, if you measure the dimension, either the dimension is not mentioned in this some whether diameter or length or whatever, doesn't matter. Assume dimension. The dimension within this particular range, then we'll accept, right? If you measure that particular item, if the that particular dimension within this particular range, 114.59 then 115.14, then we'll accept. Otherwise, we'll reject. That is the meaning in industrial term tolerance, right? How we can understand? If the dimension in between this area, we'll accept that particular one. Otherwise, we'll reject. Otherwise, means a dimension either less than the minimum value, 114.59, then it will be rejected. Less than that, now for example, 114.0, then we'll reject. Then again, other upper area 115.15. If the length is greater than 115.15, then again we reject. Right? Reject actually less than the minimum value also reject. Greater than the maximum value also reject. We accept only this particular range, the dimension value. So that is the what you call tolerance rate, right? Actually, the tolerance rate is explained in the last sentence also. See? Read that one also. The tolerance limit means accepted limits. If the dimensions are within this particular two values, it will be accepted. Otherwise, what is otherwise? Dimension less than 114.59 or dimension greater than 115 will be rejected. You can understand. Now this industrial application. How to now you can understand earlier Marx example. This is the now industrial kind of example. You have to convert the normal distribution, otherwise you will not be able to solve. Now, what is the actual problem? Now, see what is the part? Yeah, assuming normal distribution, then we the dimensions is varies based on the normal distribution that is given. Find the percentage of the articles. Find the percentage of the article which will fail to meet the tolerance. With this specification, we have to calculate how much percentage, how many percentage of the article will fail to meet the tolerance, right? That's the within you want to calculate. Actually, we first year should calculate, what is the probability of the article dimension in between this particular range. We calculate that one first, then reject calculation we can easily calculate. No? See the answer. Let x is the variable. First calculate the probability of accepted limits. We calculate the mean value is already marked here. Standard deviation, these are the given value. So we calculate this probability, right? Understand probability of the dimension between this particular two range. We calculate this one first. This like no different with the previous example. We only calculate the marks between 40 and 60. Similar. Because variable is marks in that case. Now variable is dimension. Dimension between, it has decimal values also given 114.5, less than x, less than 115.5. Now we have to convert to Z score, remember. Just want to go back to the laser point, otherwise you can't see what I'm. See now this, we are here, right? We are here. It's like a previous example, marks between 40 and 60. Remember calculation also same base. Now convert to the Z score. 114.59, this given value, minus the mean value 114.92. This calculation you can understand, divided by the standard deviation. This is Z, x minus mean by sigma is a mean Z value. See the Z here, second line. Less than 115.5 minus again mean divided by 10. If you simplify here, you get, you can use the calculator and simplify, you get minus 2.2, less than is it, less than this particular 115 minus 1 minus the 114 something divided by 10, you get 1.53. See, every time you get that particular range, every time between minus 3.4 to plus 3.4, see, minus 2.2. Now read how to get this probability. We practice, read the 1.53 from the table. If you have the table, read 1.53, 1.5. First take the 1.5 from the first column, then 0.3. 0.3, you see the 9370. No? That's correct. Correct value have been printed. 9370 minus, what is minus 2.2? Turn to the other page if you have the hard copy. Minus 2.2 is 0.0139. And now take the difference to get the probability in between this particular two values. There's a 9231. Then how many articles? Actually, remember, this is a good example because the percentage is probability is 0.9231. We are asking the percentage. If you convert 9231 to percentage, how much? 92.3, no, 2 decimal places, 1 decimal place, 92.3%. Now you can see that the mean 92% of the articles fallen within the tolerance limit. That mean here, that mean, again, that mean 92% of the articles will fallen within the tolerance limit. That means accepted limit. That means we can accept 92%. This is usually industry, is a big number, right? So we can calculate the, now we can conclude that approximately 100 minus 92 points, that is 7.7 of the article will be rejected. That is the actual answer you want to get. From this example, actually only 7.7 of the article will be rejected. That is the correct answer, right? That's the correct answer in this case. But we calculate the accepted probability and the number of percent, how many accepted, that is 92.3% will be accepted. Therefore, 7.7% will be rejected. That means out of that particular range. This is a kind of industrial application. The accepted range should be large number. The rejected percentage should be small number. Only the 93%, 92% we can accept. About 8% will be rejected. Total production 8% should be. See how useful this kind of thing is. Quality control. No. Now, for example, if the 50% of the article will be rejected, see, if you get 50% of the article will be rejected, production process, in the machine is out of control. These things, very industry, very useful because we can industrial process, the machines are out of control. That is the sampling distribution. There is some advanced statistical theories are there to get this kind of things. I think just one example. If you have the table, I think if you have the table now, you can do these exercises. You can do with me. If you don't have table, I just help you to get this, solve this equation. There is so, after that you can do some additional exercises and all that. After that, the next unit we can straight away start what you call the differentiation. And try to do this couple of exercises. I think I just have some tables and the values can be calculated. Now take a piece of paper, and if you have the table, maybe soft copies or whatever, you'll be able to do the calculation, right? Take the first example. The mean height of 500 people is 170 centimeters. Remember, these calculations are very simple, so simple. If you have the table, the mean height of 500 people is 170 centimeters and the standard deviation is 9. See, we don't have actually the heights of 500 people, that's not given, but the mean value is given. Somehow they calculate the mean is given 170 centimeters and the standard deviation is 9 centimeters, right? 9 centimeters. When you handling the large number of data, once you calculate the mean and the standard deviation of the particular distribution, so many, you can provide the answers for so many questions without observing the marks. See, without observing the marks or heights or the diameter, we can, the answer to many questions using the distribution tables. Otherwise, you have to analyze all the large data. Suppose it is 50,000 people. Suppose it is 50,000 or 500,000 people. Heights. You can enter the computer and you can calculate the mean value and the standard deviation straight away using the functions. Remember, normally if somebody enters this data into computer, just a fraction of a second, you can calculate the mean and the standard deviation using the software. Remember. You have to realize this kind of thing now. I think you can understand what I am telling. No? Suppose we have the 50,000 people marks. You can ask the data entry operator to enter 50,000 marks to the computer. In fraction of a second using formula, even Excel formula can be used. Mean and the standard deviation functions are there. You need not to use the SPSS plus like a data analysis software. Even Excel software, you can easily calculate the mean and the standard deviation. Automatically it will do the calculation value. But for the answer to the other question, now for example, if you want to calculate this here, how many people had heights greater than 185? Can you do that? Very difficult. Very difficult. You have to study all the observation, 50,000 observation. But if you know these things are distributed, normally distributed, then we require only the mean and the standard deviation to calculate all the other things. But the first part, heights between 150 and 190. If you want to get the answer for this question, you have to study all the heights, 50,000 heights, 50,000 people there. Very difficult. Now you see, the job will be very easy. If we assume these heights are varies based on the normal distribution, and the height and weight also normally, actually, if you take large number of people, height and weight also normally distributed like IQ. Suppose globally, if you take height and weight of the people, if you take the global, the very small children also, even for the infants and the all kind of people, height and weight measure, definitely the normal distribution. The mean height may be suppose 5 feet or 4.5 feet. The normal distributed. There are some people maybe 1 feet, sometimes maybe 7 feet at the extreme ends. Likewise, the similar kind of example. Now we can just work out on this one. Mean value. Just if you have a piece of paper, just write yourself. Quickly write. Your answers are not given here. I also just work out in the last class. I have some calculation has been done early for some previous classes. I can use those method, same data, right? See the here. Assume the heights are normal distributed. Determine the number of people likely to have heights between 150 and 195 centimeters. Now take your piece of paper. Now first write probability P within bracket 150 less than X less than 195. X is the mark. Remember, X is the height. X is the height. First you have to write probability within bracket 150 less than X less than 995. We have to calculate that probability, right? First write everybody P within bracket 150 less than X less than 195. Now convert into the normal standard disco. Second line should be P
Between bracket now 150 minus 170. I think you notice how to calculate the previous example. 150 minus 170 divided by standard deviation 9. Here 9. The 150 line, the first line should be become 150 minus 170 divided by 9. Less than Z, less than, what is the other Z score? 195 minus 170. 195 minus 170 divided by 9. Right? Simplify, you get minus 20 by 9 less than Z plus 25 by 9. When you simplify, you have to have the answer in 2 decimal places because the tables are prepared. Actually, tables are supported two decimal places. You see, now you get first range P within bracket minus 2.22. You get, did you get that one? If you divide the 20 by 9, minus 2.22 less than, it said less than 25 by 9 means 2.78. Now we want to calculate probability in this particular range. Use the table 2.789973. If you have the table, read the table 2.78 plus side 9973. If you read the value minus 2.22, that is 0.0132. So that line reads 9973 minus 0.0131. That will give the answer 0.9841. 9841. You know, that is the probability of the height between 150 and 195. That will every time we calculate the probability. Remember how to get the number of people multiplied by 500. Multiply that number 98.9841 by 500. Then you get the how many people? How many you get? 400. Then remember when you multiply, don't convert number of people. You can't have the number of people 50.5. Half people convert to the nearest whole number, right? Nearest whole number. 492. Right? I think you get the answer, no? 492. I just give you a few minutes, right? I just give you a few minutes, maybe 5-10 minutes. To do the second part. Second question is the same problem. See, for the group of people given in the problem 1, find the number of people likely to have heights of less than 165 centimeters. Now try to do yourself and give me the answer. You can tell me the answer, right? Now do the problem 2. The same, same mean and the standard deviation can be used. So you want to find out how many people likely to have the height less than 165 centimeters. If you get the answer, you know, you can send me. You can just use the chat option. You can send me the value. You can just tell me otherwise. But anyway, we winding up the session quickly because because that problem, because some student cost, not some, everybody cost about the connection. So next week onwards, I just talk to Mr. Yujat and get some information about the, how to send the connection to you, so you'll be able to connect that particular link and start the session rather than using the meeting ID. If you use the meeting ID, I think that will cost for the data. We'll solve that problem. Therefore, I don't like to continue to start another one today. That is a probability part, of course, finished, right? Probability part will finish today. We solve this question first, then we winding up the sessions. Next day, with the new connection, we try to continue. So, how many get the answer? Very simple. By this time, we'll be able to get the answer. But the answer x less than 165. The first line should be x less than 165. The convert to Z score. First one x minus 170 by 9. That's Z, no? Z less than 165 minus 170 divided by 9. That is minus 5 divided by 9. And that you get Z less than minus 0.55. Read the table from the minus side. Minus 0.55. That value is there, no? Minus sign, point, 0.5. 0.5 you have to take it from the other column. 0.5 minus 0.55 has to be taken from the column 0.5 column. Then you get the 0.2912. 29, yes, 2912. Everybody get that value? 2912. Then multiply by 500. Multiply by 500. What is the number you get? It's very simple thing. 146 to the nearest whole number. 146 people. Out of 500, 146 people's height is less than 165 centimeters. That is the second part. Similarly, you can have the final part also. The height greater than, do that one also, height greater than 194 for the group of people given in the problem one. Same mean and the standard division you can use. How many people are likely to have height more than 195 centimeter? At this time, I think we cannot exclude many people because see the mean is 170 centimeters and standard deviation is 9. Right? You know, the mean value is very less than the 195. Even the mean plus sigma is 179. Mean plus 2 sigma also give 178. At least this is the, you know, the belongs to the mu plus 3 sigma range. There is only few people. There may be few people. You can take, assume actually height is 195. It's a big height. You won't get many people. You calculate and see. Just start x greater than 195. That means z greater than, that x minus part is not necessary to write every time. Just put z, right? X greater than 195. Then z greater than 195 minus 170 divided by 9. I think by this time you'll be able to understand how do you calculate the, you know, the z value. 194 x minus mu by sigma every time. X is 195, the value we want to consider, minus mean value 170 divided by 9. You get 24 by 9. That is z greater than 2.67. Take the calculation. Z greater than 2.67. 2.61, 1 minus that 2.67 reading. If you refer the table 2.67, if you don't have the table, write this value 0.9962. 1 minus 0.9962. 0.9962. So P equal 1.9. P equal, so 1.9. And just, you know, so you get 0, 0 something, right? 1 minus 9962 means you get 0, 0 something. If you multiply that number by 500, then you get the 1.9. You calculate that particular number. I don't have calculator here. 1 minus 0.9962. Then you get 0.00 something. Multiply by 500, you get 1.9. What is 1.9 people? Approximately 2. No? 2 people. Only 2 people. Out of 500, onto 2 people approximately having, these are only approximate calculation, right? Only 2, not exactly 2 people. We assume it, right? Because we don't know the data. These are kind of assumption can be made. Approximate calculation using the normal distribution. These are not the exact value. Maybe if you observe the real height, there may be slight difference. Maybe 4 people, 5 people sometimes. It depends on the variable, right? Here see the two people, right? Now see the good example, industrial application of this kind of thing, the final one. Better to do that one also because that's the industrial kind of application. Just you finish, then you can start the final one. See the read the question, right? A batch of 1,000 lemonade bottles, a batch of 1,500 lemonade bottles have an average content 753 milliliters, right? What is this value? How to explain this problem? Normally, now if you see the lemonade bottle, maybe normally they specify, you can't see the bottle content, nobody want to specify 753, no? Should be 750, no? Can you remember? Normally the bottle content, why machine is set to produce, that this industrial application, normally, the automated process, the machines are, the filling bottle process is fully computerized nowadays. Lemonade or whatever this soft drinks production process is fully automated nowadays. So the machine is set, actual machine is set to fill each bottle with 750 milliliters. Now try to understand the real problem here. Normally machine is set to fill the bottle with 750 milliliters, right? But if you observe the sample of 1,000 lemonade bottles, that give this particular value, because we can take, for example, in this survey they can take 1,500 bottles from the production line. They are normally taking at the same time, maybe in different time intervals, right? When you want to do this kind of survey, they are taking the bottle with different time intervals, choose 1,500 bottles and measure actual content. They measure the actual content and take the average value, right? They take the average value. And that average value will be shown here, 753 millimeters. And if you enter those values to computer, then easily you can calculate what would be the standard deviation of this, because values are very close, no? Sometimes 750, sometimes 750.1, sometimes 752.9. Likewise, the volume may be slightly changed. They observe the standard deviation of the content is 1.8 milliliters. See that? For example, 1.8 milliliters. The deviation from the mean, the actual mean, the 750, actually, machine is actually set to produce lemonade bottle with 750 milliliters. But there may be slight deviation, 1.8. Right, you can understand very small difference, no? Very small difference. That is the standard deviation. Those we have to assume the mean is a given, no? Average content bottles have an average content. Average content is a mean, no? Average content is 753 and standard deviation 1.8 milliliters. In this case, remember, just write down mu is 753, sigma is 1.8. If the volume of content are normally distributed, we have to calculate, just I show you how to calculate one, then you can do other things. But like to contain less than 750 milliliters. That's the danger. See, we have to actually calculate how many bottles are like to contain less than 750 milliliters. Now see this example. If many bottle filled with less than 70 milliliters, then people might complain, no? People might complain because because the production is out of control. The production is out of control. Now we have to check now. Using the normal distribution, we can check with this sample survey what with how many bottles actually less than 750 milliliters. You can calculate. You do yourself now, right? Probability, you want to calculate probability first, less than x less than 750. If you don't have table, just write You can hear me, no? Just write. Just P within bracket X less than 750. Because answers are not prepared here, right? That's what I'm reading. The similar kind of example we did earlier, Now convert to Z. First part you need to write X minus 753 divided by 1.8. You just write Z straight away. Z. P Z less than. We have to simplify that part. Z less than 750 minus mean value 753. 750 minus 753 divided by 1.8. That's the important part. The second line should be probability within bracket P within bracket Z less than 750 minus 753 divided by 1.8. Right? Simplify that. 1.750 minus 753 means minus 3. Minus 3 divided by 1.8, you get minus 1.7. Right? Z less than minus 1.67. What is the Z less than minus 1.6? Straight away the table reading. Remember, less than, no, straight away table reading. It will read 0.0475. 0.4075. Actually, there is less probability. The bottle contain the lemonade less than 750 millimeters. It has a very small probability, 0.075. If you want to calculate the number of bottles, multiply by 1500. That number multiply by 1500 and tell me the number you get there. You have the calculators, no? That's the probability 0.475. Multiply by 1500. See how many bottles you get. In this survey, how many bottles you get less than 750 milliliters.
$71.25.
Yeah, 70. You can approximately take 71 bottles, no? 71 bottles. Actually, that's good. 71 bottles is not many, no, not many. Out of 1,500 bottles, only 71 we assumed 71 we can expect less than 750 milliliters. That's not very bad, no? That's not very bad. 71 less than that number. So similarly, you can go for the next one also. Between 750 and 754. Now we have to write probability P within bracket 751 less than X. First X variable. X means the the normal standard, no, volume in millimeters. X less than 754. 751 less than X less than 754. Convert to Z. The middle one just straight away you can write Z, right? First one 751 minus 753 divided by 1.8 less than Z. It's not necessary to write, the X minus or something like that. Final one 754 minus 753 divided by 1.8. Shall I read it again? Second line, probably 751 minus 753 divided by 1.8. The first value less than is it less than 754 minus 753 divided by 1.8. If you use the calculator to simplify, you get minus 1.11 less than is it less than 0.56. One is negative, one is positive. Minus 1.11 less than is it less than 0.56. Read the table 0.56. Read the table value 0.56. That is, we don't have table, just write the value while tell 0.7123. If you have the table, you can check the value, right? Positive side 0.56 means 0.7123 minus 1.11 means 0.1335. 1335. That will give the difference 0.5788. That is the probability. Probability 0.5 mean actually half of the bottle, no? Half of the total bottle. To multiply by 1500, you get 868, no?
Yeah.
868. Now you see it's not bad. Out of 1500, 868 bottle contain 751 and 754. Just small content is there, no? Actually the bottle content should be 750, no? 750, but it has half of the bottle, that particular number. It has the volume 750 and 752. So like that, you will be able to, I think, more than 757. More than 757, you can again that can calculate. X greater than 757, the third part. That is the body. That's the serious problem. If the volume volume content more than 757 means actually the bottle content should have the 750 milliliters. No, the company losing. No, company will provide some additional lemonade for the customers with the same price, right? 750 bottle also same price. 757 bottle also same price. The company now, for example, in this case, if the production in this production produce a very big number of bottle with this volume, the company losing. Calculate probability X greater than 757, Z greater than 757 minus 753, that is the average, divided by 1.8. You get 2.22, no? Z greater than 2.22. Now we have to read the table value. Take 1 minus that number, because greater than, no, it will show the other side, right hand side, the area. We have to get the right hand side area, we have to get that, but normal table left hand side. So we have to do 1 minus 0.9868. You read the table, 1 minus 0.9868. So that will be very small number, no? 0.0132. 0.0132. If you multiply by 1500, you get approximately 19 point something, no? That is 20, approximately 20 bottles. They're not bad, because only the 20 bottles out of 1500 had more than 750 milliliters. Actually, we can actually assume this production line, production process is under control, not fully under control. If it is actually fully under control, the mean value actually we can't have 753, right? If the production is actually fully controlled, the machine is perfectly work, you can have the 753 also, the 3 milliliters excess. That's what every time the even 757, it has 20 bottles. The production is fully out of control, but control of course, but not fully out of control. You see that for this kind of thing, you can without observing all the information, you can come to the conclusion of certain matters. So therefore, this is a kind of the industrial application of the normal distribution. And that is just question of the one day, the previous day, the DST student. A good question, of course. He's asking why they using normal distribution other than the standard normal. Why other than using the normal distribution? The normal distribution actually, the different fields, mass, in this case the volume. Sometimes the previous example, height of the people. The industry variables are different. Remember, education, it is mass. Industrial, in this case, the volume of the lemonade bottle. Previous example, height of the people. Sometimes IQ. How can have the common table for different applications? So whatever the application, if it is distributed to the normal distribution, So we can have the common standard normal using x minus mu by sigma. Even the A level also how to prepare the Z score. For example, Z is x minus mu by sigma. Now, for example, suppose you done A level, suppose 1 year, suppose A level mean mark is 60 subject, standard deviation suppose 10. Suppose if you score 70 marks, what is it score? 70 minus 60, 10 divided by 10, you get 1. Is it score 1? That particular subject. If you have the 50 marks, then your Z score is a minus 1. Because minus, no. Z score is sometimes minus, sometimes plus. But it won't go beyond that particular range. Remember, Z score every time, minimum minus 3.4, maximum 3.4. Very rare student get the the near close to the 3, but some student get score. This is how to calculate the score for the one subject, right? Then normally they take the kind of average to get the depends on the number of subjects in the examination. If it is a 3 subject, your average has to be taken. Then that is how we define the Z score also, remember. So any situation, this normal distribution is very important. See in this final example, how useful in industries. Therefore, this is useful in any kind of industry. Finally, you can actually calculate the between 750, 750 is a good example to calculate. Even I don't have the calculation. We will finish this, finish with this calculation also. Because I can do it because I have tables here. So do the final one. Here between 750 and 751. Very good part here. Now this is almost the expected limits now. Actually, bottle should be very close to 750. Now calculate this particular value how much. Is the right probability 750 less than x less than 750. I also not calculate because I don't have previous calculation. So the probability 750 minus average value 753 divided by 1.8. Middle one just straight away just write is it. 751 minus 753 divided by 1.8, and I use the I don't have calculating. I just did my just do yourself. I just when I just my phone is somewhere there is charging, right? I'll bring it. All right, now 750 minus 753 is minus 3, no? By 1.8 less than Z less than that is a minus 2 there, no? Minus 2 by 1.8. See the calculation 3 by 1.8. 3 1.8 should be minus, that is minus 1.67 less than Z. Other one is 2 divided by 1.8, that is minus 1.11. See the both values are minus.
Yes.
The table minus 1.67 minus 1.67, you get 0.0475. 0.04. You have to take the other one first, right? You have to take the other one first. Just read the first one, minus 1.11 first, right? Minus 1.11.
0.0485.
Minus 1.11. Minus
0.0485.
1.11 mean 0.1335. Minus 0.11 means 1335. 0.1335. Correctly read the table, right? Then
1335, right?
1335 minus 1.67 means 0.475. Now take the difference. 0.1335 minus 0.0475. You get very small value 0.086, right? 0.086, that's the probability. 0.086, that's the probability of having the volume 750, 750. That's the probability. If you want to calculate approximately how many bottles, multiply that number by 100,500. you get 129 bottles. We see the even out of 1,500 bottles, there are 129 approximately bottles still we have in this particular range. Less number because the average is a little bit high. That is the reason. Average is little bit
excuse
high.
me sir.
Yes.
දැන් සමහර වෙලාවට සර් අපි අර වටේල ගනිද්දි මේ දැන් මට ආවේ 128. එතකොට දැන් ආන්සර් එක දෙද්දි මේ 129 නැති වුණොත් එහෙම හරි ඒ කියන්නේ
you want to get the problem. That the approximate answer is expecting no answer. I'm ඒක ප්‍රශ්නයක් නෑ.
හරි සර් හරි thank you.
අපි දැන් මේ I think we'll wind up the session because of that problem. I just want to solve this problem. Maybe from next week onwards, we try to coordinate. I think I didn't apply. When I creating the schedule, I didn't apply. That Saturday is there. I try to next time I send you the link, kind right? I send you the link. This first time we will be doing these things. So that may be the problem. Okay. Now this is the probability part is finished. I think we'll wind up the session. Okay, we'll continue maybe next week. We try to actually send the link other than the meeting ID, so you can have the connection without cost any cost. Okay, right?
හරි සර් thank you sir.